The temperature of the planet has increased uncontrollably in recent years. Climate change demands urgent action. Green hydrogen is an indispensable element. 100% emission-free and applicable to all sectors, including those that are difficult to electrify. Essential to drive Europe's decarbonisation, ensure its energy autonomy and strengthen competitiveness. Europe is making steady progress with decisive milestones. Spain is at the forefront of the energy transition in Europe. It is one of the first countries to start transposing the European Directive on Hydrogen and Decarbonised Gas, with a national integrated energy and climate plan that raises Spain's commitment to hydrogen by 2030, major hydrogen production and demand projects, and with an essential infrastructure network to connect supply and demand. Enagás, as provisional hydrogen transmission network operator, has a government mandate to develop the Spanish hydrogen network and the H2Med corridor, projects recognised as being of common interest by the European Union. These projects, which are progressing with the launch of a public participation plan throughout Spain. Together with its partners GRT Gas, REN, Terega and OGE, Enagás continues to work towards making H2Med a reality from 2030 onwards, with the launch of the first market consultation of a pan-European hydrogen infrastructure. Spain and Europe have very clear objectives. Green hydrogen is advancing. Hydrogen is now.
We are sending this event via streaming as well, so thanks for joining us, all of you that are here and those following this event via streaming. You know, we launched this technical day 1 year ago with the intention to sharing the evolution of hydrogen technology in the deployment of the hydrogen economy in Europe, with a special focus on the infrastructure needed to make a reality the hydrogen market in Europe. In this year, many things have happened. We think that hydrogen has made a very significant progress in all fields, in the regulatory, the infrastructures, the technology field. We will have a look at this last angle, the technology angle. But it's very important to bear in mind the main steps that have been taken. You know that we've got a new European Commission in place with a very clear roadmap to develop the hydrogen economy. We have the competitiveness compass, the clean industrial deal, following the recommendations of the Draghi report and the Letta report. The hydrogen infrastructure is a key element of the strategic project for Europe of decarbonization, competitiveness, and strategic autonomy. Member states are also making very significant progress. This is the case in Spain, where Enagás, together with our colleagues of Portugal, France, and Germany, are pushing forward the H2Med corridor with infrastructures as relevant as Barmar or the interconnection with Portugal. Also, we are developing as we saw at the video, the Spanish hydrogen backbone. We are beginning the deployment of the public consultation process as a PCI. This is being done at a scale never done before in Spain. We are talking about 2,600 kilometers of linear infrastructure, 550 municipalities being involved, 13 autonomous regions. This is going as scheduled, very, very well, I would say. We've already gone to 60 municipalities, having meetings with the neighbors, with local agents, to explain the characteristics of this infrastructure, the value that these infrastructures are going to create in local communities. We are now carrying out these meetings in Extremadura after Castilla-La Mancha, and in 1 month time, more or less, we will be starting this process in Andalusia as well. I would like to announce today that we have already signed the grant agreement with the European Commission for Enagás to receive 32.5 million euros to develop the studies and engineering works of this Spanish hydrogen backbone. So, as I said, everything is moving forward very well. All in all, this is happening in all European countries, bringing together the national energy and climate plans of the different EU member states. We have 21,000 kilometers of planned hydrogen infrastructure with a combined investment of 60 billion euros. We have a panel today with several European TSOs which will also address the advances in the national arena. We've also had two very important auctions launched by the European Hydrogen Bank, which is helping us to have a clearer vision on how the European hydrogen market is taking shape. The second auction results have been announced very recently, and they give us very important messages. One of them is that technology is playing a decisive role in the acceleration of hydrogen economy. We've seen, for instance, that the average cost of electrolyzers has reduced to a range of 735 to 901 euros per kilowatt hours, depending on whether we are talking about alkaline or PEM technologies. This is the same message that we received in the workshop that the observatory, the Technical Hydrogen Observatory, carried out in April with many actors, including some OEMs like Cummins. In this second auction of the European Hydrogen Bank, we've seen that 38% of the projects have a direct connection, total or partial, between the electricity generation and the electrolyzers facilities. This shows that the, let's call it, off-grid mode or island mode is gaining ground in the development of the hydrogen business models. 75% of the aggregate capacity of the projects come from made in Europe electrolyzers. EU is home to 9 of the 15 leading world electrolyzers manufacturers. An additional key message is that Spain is really becoming the great hub of the green hydrogen in Europe. 36 out of 61 projects submitted to the auction came from Spain. Out of 15 of projects having received the premium comes from Spain. This is very, very relevant. And this is because Spain is able to produce the most competitive hydrogen with 5.5 euros per kilogram as an average price of the projects submitted from Spain. One more point. There will be no European hydrogen market without infrastructure. 64% of the projects submitted require an infrastructure, a linear infrastructure connecting production and consumption, with an average length of 300 84 kilometers in each project. This is the end of the notion that hydrogen valleys will be the primary way of deploying the hydrogen market in Europe. We are talking about a very important network connecting, as I said, production and consumption areas. Technology is really keeping the pace and is supporting this process. Technology is maturing very fast and will continue to gain momentum in the coming years. But definitely, this is a big challenge in terms of logistics, of technology, and it's very important to have fora in which to exchange views and identify the best way of addressing these challenges. This is why we consider this forum is so relevant. And in this second edition, we are trying to address two main perspectives. First, how digitalization is going to optimize the design, construction, operation, and maintenance of the hydrogen assets, promoting new ways of working with replication, monitoring, and predictive analysis. In the first panel of today, we will see how AI has a key transformative potential for developing the new hydrogen networks. By applying building information modeling, BIM solutions, and developing digital twin technology for infrastructure, making them smarter and more efficient by integrating multiple energy vectors into a single digital model. A second aspect we want to highlight is the crucial role of OEMs, of original equipment manufacturers. You know that we need to ensure the availability of the key components of the infrastructures, and in that regard, large-scale OEM production of components such as compressors, pipes, valves, metering systems, electrolyzers, turbines is absolutely essential. There is also some elements with a transversal role, and innovation is perhaps the most important of those. You know that Europe is leading this process precisely because Europe is betting on R&D. In the last 5 years, 3.3 billion euros have been awarded to hydrogen R&D projects in Europe. That's why Europe is also leading the patents in the hydrogen field. 28% of global patents regarding hydrogen come from Europe, compared to 24% from Japan or 20% from the US. Spain is playing also a relevant role in that regard. Spain is among the 10 countries with the most number of patents in this field. A last message to conclude. Collaboration is key for the effective creation of the ecosystem needed for the taking off of the hydrogen economy and the hydrogen infrastructure. That's why we think this kind of fora are so crucial. This is why 1 year ago we launched the Hydrogen Observatory, creating a meeting point in which to exchange views, to be as fast and efficient as possible, as finding the ways to address these challenges that we still have in front of us. The observatory now has 60 leading partners across the value chain. We have companies, producers, consumers, OEMs, universities, technical institutes. We have public bodies of all sorts. So we think that we are really meeting the aim of having a very useful meeting point for all the value chain. Finally, I would like to end by expressing my gratitude to all the speakers today. Thank you for making time in your agendas to come to Madrid and share your views with us. Also to our partners, these 59 partners of the observatory. Thank you also to the observatory team for the work you are doing. I think you are doing wonders with the resources we have. And I hope that this session today will be useful to all of you. So thank you so much. Enjoy the meeting. And I will give the floor to Emilio Nieto, Dr. Emilio Nieto. He is the director of the Spanish Hydrogen National Center in Puerto Llano, and he's going to give us an overview of where are we standing regarding hydrogen technology. Thank you so much. The floor is yours, Emilio.
Okay. I was asking where are the machine in order to pass the transparency. So good morning to everyone. It's a real pleasure to be here. Thank you to Enagás and thank you to the observatory team and also all of you for having me the opportunity in order to give you, I have only 10 minutes and now I saw it's less than 8. So it's a lot of information I want to share with you and I have no time enough, but of course during the coffee, I hope we will have the situation in order to discuss more than in detail. This is a study. It has been done in Spain with the Spanish Hydrogen Association, asking all the companies about how are the projects they are running and they want to run, because you are seeing now on the bob is the technology readiness level. So is the how are the projects close to the market or even in the early stage in order to develop the technology. And you can see we have more than 360 projects in Spain. They are not all, because there are a lot of different companies who decide not to share the information with the rest about the ideas, specifically when you are talking about early stage and lower TRLs, in order not to give some, let's say, advantages to the rest of the competition, you know, in order to say, I don't want that the rest know that I am working in order to improve, I don't know, whatever will be the technological parameter from different technologies. But you can see we have a lot of different projects. Some of them, one of the key messages, I think, is that if you see the map, there is no any community without any proposal, and this is quite good. And this is also good because Enagás analysis from the introduction that Arturo has been made, it has been considered all the whole value chain and all the different territories in Spain, and this is quite important. And you can see here, sorry, it's a lot of information. I was trying to skip the most of them. The presentation will be for you, but I want to say that 9 projects is in operation right now. And you can see during the next years until 2030 or 2031, you can see we are adding 3, 36, 15 evolving projects in order to integrate it within the whole value chain of the risk. So at the end, I hope not all the 360, but enough information and enough projects it has been finishing in order to comply with the objective we have here in Spain in order to have on 2030 12 gigawatts of electrolyzer already installed and in operation. Financial investment decision, the key point. We have 6 already running now, and you can see in this year we will have more than 60 projects who will arrive to this point, and we are starting in order to think how will be the evolution of that. And all of those, we are running more than 35,000 million of euros, and also funding with the rule of 2/3 and 1/3 that is already defining here with the verde projects on application. And the back information, and for me is the most important, which kind of technology you can see here is well balanced. It's 50-50 between alkaline and polymeric. There are some projects who are blending both, and also, as you can see at the bottom, there is one project who are considering the high temperature technology is the solid oxide electrolyzer. If we go to the other part, these applications, we have most of them the common application that you can see that is oil and refinery and also the fertilizer. But there are also a lot of different projects who are considering the new energy vectors, let's say, so ammonia, methanol, and how in order to start, in order to push and go to the next step of the projects. About the barriers, the last two slides I have is focusing on the barriers, but you can see this is a very good match. And this is a good news, I mean, because the industry, the thing that the barriers we have is the same that the technology people think that are the barriers we are having. So this is a very good alignment, and this is a problem on the regulation. I mean, not a problem, but we need, in order to work all together, in order to improve the regulation, to define and try to specify more how is the hydrogen integrated into the regulation we have now. We have to balance the offer and demand, and this is quite key. And also, we have a problem in the access to electricity. And we will see in the next slides that between 60 and 65% of the cost of the kilogram of the hydrogen is due to the LNG. So it's quite important in order to have that. And also, the last three is access to finance. Of course, we need money in order to advance to the water and the land, and also to the equipment. I mean, not only because we don't have the equipment, but the equipment is not, let's say, generally speaking. So when you need 3 or 4 or 5 electrolyzers, they are not already on the market, and you need to wait time in order to have the people who are working there in order to continue proceed and move fast. So challenge. I was trying to divide in 2 slides. Some of them are general challenge, and the other one are more focused on the technology or the technical challenge. The first one is the cost. As I told you, 60–65% of the real cost of the hydrogen is due to the energy, and all the rest are a combination of all the different things, and of course all the stakeholders are trying in order to work all together and collaborate. And for me, this is a key message that Arturo has been already sharing with you, in order to continue working and all together to be able to reduce this production cost, let's say, in order to increase the competitiveness of the sector. The infrastructure, nothing to say, because Arturo has been explained quite well, better than myself, that we need the infrastructure, and we need to break the chicken and egg problem. I mean, and not to say that if we don't have infrastructure, it's not possible for us in order to continue working on the hydrogen, and this is something that, of course, we need to break this kind of challenge and try to move ahead. We need to increase and improve the regulation, as I told you before. This is quite important. I mean, it's not a question of having let's say, a regulatory framework for everything, because we have a lot of this regulatory for the gas, biogas, and we need to adjust, and we need to integrate the hydrogen within this regulatory. And of course, in some of the cases, we need a new regulatory framework, and we need, in order to continue working on that, in order to have until the end a new regulation who comply and integrate the hydrogen economy already there. We have to balance, as I told you before, the offer and demand. This is the key point. And Arturo has been mentioned the valleys, the hydrogen valleys. This is a very good tool in order to balance all the whole value chain of the hydrogen, and try also to working with the people who need this hydrogen and who need how to integrate this hydrogen into the process. And not only the typical applications, but also the new application is necessary in order to continue working on there. We need money. So we need to work with the banks, we need to work with investors, we need to show them that this is a very good sector, and of course even the cost now is a little bit higher. We are moving step by step in order to reduce this kind of impact, let's say, into the balance, you know, the economical balance, in order to continue working on there. And the last two, for me this is quite important. I mean, we need, in order to integrate the society, and Arturo, it was 2 months ago, he has been already made this presentation to the public social centers of the infrastructure planning from Enagás. And this is something, meetings like this is very important in order to report and inform the people which is the hydrogen, which are the advantages of the hydrogen, and of course, which are the challenges we have in order to reduce this manipulatory or this maintenance in order to continue working on there, and the workforce. I mean, and always when I have the opportunity in order to spread these kind of things, I have only 1 minute left, so it's not only university grade. we need also to think about the people who are here in Spain is professional formation. This is the people, the technical guys who are working in the different workshops. This is quite important, and we need in order to pay attention to that, apart from the high degree people that in the universities that is already integrated this kind of information. And from the technical ones, I mean, all of you, I see a lot of good faces here, a lot of friends here that you know more than me which are the challenges, but we need to increase the efficiency of the electrolyzers. We need to work also with the new technologies, the anionic and solid oxide, the high temperature, how in order to evolve this, in order to solve some of the challenges we have when we are thinking to use the alkaline and polymeric electrolyzers. We need also try to use and think how it's possible to blend the different renewable sources. And some of the new projects is, at the beginning, all of them are concentrated or 100 aeolic or 100 photovoltaic, and now you need to play in order to increase the time of working of the electrolyzer and try to blend these kind of renewable sources, and you need to integrate this into the process. How to store the hydrogen, apart from the pressure and apart from the liquid hydrogen, we need to think and try to guess how will be the new materials in order to increase the amount of the hydrogen to be stored, because we are talking about millions of tons. We have to working with the new materials, not only for the transportation and infrastructure in order to avoid this embrittlement project with the hydrogen, but also try to create and think how is the possible in order to have these new materials. The transport infrastructure, as Arturo has been explaining to you, and also the integration of the system within the grid, and how in order to also improve the durability and the performance of the different equipment we have. I mean, now we are more or less about 60% of the efficiency, and we need in order to increase this kind of efficiency, and this is something that the future, maybe we don't have time enough in order to see, but in 20 years' time, the electrolyzer will be working with more temperature, will be working with more pressure, and this is something that will increase also the efficiency of the different systems, because we are talking about the thermodynamic. I mean, this is the theory. So the theory of the chemical reaction is like this. So you need in order to think how it's possible to integrate this kind of system much better than the rest. And this is the information. I comply with the time. Sorry, it was very quick overview about there, but I will be here, so we have time in order to discuss with you and try to share all the views. So thank you.
Tiempo apremia, pero está muy bien.
Yes? Oh, okay. Thank you. Good morning, everyone. Thank you, Emilio, for your engaging speech. Although the green hydrogen technology is at the commercial stage, we have some issues to be improved: the electrolyzer efficiency, the production cost, the importance of talent, aspects that we are working really hard in order to improve, and obviously this will help us to improve the hydrogen competitivity. So let me introduce myself. My name is Igor Pagazortundua. I am the head of Innovation and Technological Development at Enagás and the Hydrogen Technology Observatory as well. I am delighted to be your host for today's event. We have a very busy agenda and a very interesting one. We will try, all of us, being on schedule, so please, moderators, be like that. And before we start, let me extend a warm thank you to all the speakers and the participants and the guests that are joining us today, and those who are following us on streaming. So let's start. We will start with the first roundtable. Automation and digitalization, together with the energy transition, are set to transform the global industry. In the case of green hydrogen, the rollout of new green hydrogen infrastructure, as well its operation and maintenance, can be enhanced and accelerated thanks to the digitalization of its processes. So let's start with the first roundtable that will be moderated by our Chief Information and Digital Officer, Pedro del Castillo. Please come to the stage with the rest of the panelists.
Good morning, everyone, and thank you as well for joining us for this roundtable titled Digitalisation as a Transformative Pillar for Entire Cycle of New Hydrogen Infrastructure. Well, in the next few minutes, we would like to explore a little bit more how digitalization can drive the whole processes that compose the value chain of hydrogen. Arturo was telling us this morning design, planning, construction, maintenance, operation of these new assets. And in this way, I think that we have different points of view and we have the privilege. I'm going to first of all introduce our panelists. I would like to welcome Nina Bergman from Siemens SA. She recently came from Munich to Spain to join the executive office of Siemens. And only 2 months here in Spain, so welcome as well to our country. And Nina is the lead of the strategy, or the lead of the sustainability strategy and execution at Siemens, Portugal and Spain, across both internal operations and also customer solutions. We also have the privilege to have in the table Natalia. Natalia is our lead, in fact, in one of our strategic projects that we are leading right now in Enagás. She's from Natalia Matute. She's from BIP Consulting, and she's the director of building information modeling in Spain. Okay, she's helping us as well, as I said, to implement BIM information, building information modeling in our processes in the new structures. Okay. And also we have the privilege to have another panelist, but unfortunately she missed.
He just came in.
Okay. So Roger,
just on time.
Roger, just on time. So fantastic. I'm going to introduce you while they wear your microphone, okay? Roger is a Catalan institution for research and advanced studies in Rovira i Virgili University. He's a real expert in everything related with complex system, complex network structures, and his last research focuses. Welcome, Roger.
Thank you. I'm sorry. Thank you.
And his last research are focuses in in the computational and new ways of implementing digitalization in new projects and Bayesian simulation models. So welcome, Roger. It is important to say he's very prudent, but it's important to say that he have earned several prestigious international awards. So it's a big privilege to have you here.
Thank you for having me.
Okay. So just to begin, and let's start because we don't have, you have 30 minutes, so I think it's okay. But I would like to start with a general question, okay? As I said before, digitalization is expected to change completely the way of thinking different processes in the value chain of hydrogen. As I said, construction, deployment of new infrastructures, and so on. What do you think, from your experience, is the big challenge, or the biggest challenge, or the biggest opportunity to make this transformation truly effective? So would you like to start, Nina, and we can follow the
Yes, I can start. So first of all, I hope you guys can all hear me. As said, I'm Nina. I'm super happy. Thank you. Thanks a lot for the invitation. I just moved to Spain 2 months ago. I love it. I've been with Siemens for almost 6 years, so I think it's a little bit similar to Enagás, right? You join Siemens and then you like it a lot, and then you stay for a little longer. And now I have gotten this opportunity to lead the sustainability strategy for Spain and Portugal. So about the biggest challenge, I think we already heard so many of them, but what we always say is the biggest challenge in this transformation is to achieve real efficiency. Why do you need that? Because we heard that hydrogen projects are still very complex, they're still very cost heavy, right? And there are a lot of challenges in the ecosystem, there are a lot of challenges in regulations, there's uncertainty, there is still, and it's still a comparably new technology, right? So there's still a lot to learn. It's always good to learn a lot, but in order to, in order to be really efficient, there's a lot you can, in order to be price efficient as well and profitable, there's a lot of efficiency that you have to achieve. How can you do that? With digitalization for sure, but you need to do it comprehensively. So you really need to have that data flow, to have that system integration between different systems. You really need to think it comprehensively, and you really need to think about how can you actually scale it. So there's the feasibility part, are the projects technically feasible, are they profitable, but there's also this part of how can I actually scale things up, right? It's not only about making one hydrogen project work, it's about scaling up, it's about making more of them work, and about generating long-term value. So how can you do that? How can you be really energy efficient? How can you be process efficient? How can you be proficient in your engineering? So all these things need to be considered. And then there's another point that I always try to make, because I'm the sustainability responsible, right? You really have to think sustainability all the way, because there's no point in just simply more or less producing green hydrogen if you use a lot of components, a lot of materials that are not really sustainable on the way. So really think comprehensively and think sustainably along the way is what we see as one of the solutions to the biggest challenges.
Okay, thank you very much, Nina. Natalia?
Yes. I think, Pedro, that the major challenge is human factor, so changing how people work. We often think in digitalization like models, data, platform, and so on, but the real transformation is when the people change their routine. So, for instance, the collaboration in a project, we are adopting new tools like common data environments or CDEs, that are not just a new tool, are tools that covering all the traditional activities that we normally develop in a project. So, but in this case, inside of the CDE. So, approval, shared documentation, communication with other stakeholders. This is the activities that we have to do in a common environment. Okay, so to change the work methodology of the people is not easy. So for a company, it's a cultural shift and also takes time. Another example, Pedro, is like standardization. So if we're thinking about project managers and also other people that are working in a project, each people works in a different way. So we have to, if we think about digitalization processes, we need consistency. So we have to implement standards, rules, and so on. So in order to converge all these different works and ways to works in a single one. So I think that digitalization and also technology is the key, but together with people that are makes the transformation more effective.
Okay, thank you, Natalia. That's a good point, no? Everything related with people is completely, it's a must, in fact, no? Okay. Roger.
Okay, so first of all, thank you very much for having me, and apologies for the momentous entrance.
No worries at all.
Well, because I'm coming from academia, I think I will do what we do in academia, which is say things that are perhaps not very useful, but deep, right? So, So I think we have to step back and think why we are here, right? Why we are talking about digitalization, why. And the reason is because we have a major challenge, which is transforming our economy, basically, right? The way we generate energy, right? And then I think this is unprecedented in history. I was thinking about this when I was coming here in the train. And I think it's unprecedented because we've done transformations, right? We've done the industrial, well, our ancestors did the industrial revolution or whatever, right? But I think it's the first time that as a species, we sit down and say, right, 2030, we have to change everything we do, right? So I think that's the real challenge, right? It's a major challenge. And then the issue with that is that we don't have time for trial and error, right? We don't have time to go and try, well, let's try to do things this way, or let's try to do things in a different way. And I think that's what's behind the idea of digitalization, right? We are doing digitalization because we can do it, because we've learned a lot of things, but also because we have to, because we don't have the opportunity or the luxury of trying things, right? In what way does digitalization help us in this sense? Well, it allows us to build models and to predict what's going to happen before it actually happens, right? I think that's the real goal that we should keep in mind, right? Again, as I warned, I'm from academia, so I can say these sort of things, right?
Yeah, right.
We have to make sure that digitalization helps us in choosing the shortest path between where we are now and where we want to be in 10 years or 25 years or whatever, right? So that way we need models, that way we need digital twins. There's a lot of talk about digital twins, which are digital models of physical systems which help us to predict what's going to happen before it actually happens, right? So that we don't have, we avoid this back and forth that typically happens when we go through a revolution. And for these digital twins or for these technologies, there are two requirements. One is data, and the other is that we make sense of the data and transform this data into models. And my impression is that for the last year, perhaps 20 years or something, we've put a lot of emphasis on building data infrastructures, right, on collecting data, but we've somehow forgotten the other half of the story, which is getting knowledge from this data, building models that actually work, that actually help us make predictions about our systems. And this is what I think is the biggest challenge in digitalization, right? I'm not in a company, so I don't have to deal with the human factor or the other things. But from the academic perspective, perhaps, or from the perspective of what is the sort of knowledge that we need to generate, I think that's the key. We need to be able to design artificial intelligence algorithms, or perhaps physical algorithms, or whatever, that help us transform this data that we've been storing for a very long time now, or a reasonable time now, into useful models that actually make the path shorter to where we want to get.
Okay, I agree. Thank you very much, Roger. Yeah. Well, let's move to another question. I would like, in this case, to pitch you specific questions more tailored for your profiles, your specific profiles. I'm going to start with you, Natalia, if you don't mind. And I would like to ask you, because you are the person responsible for building information modeling at BIP, what do you think is the next step for BIM and for digital twins to pass through the static model or a static vision, to pass to a real living model and something that can really impact to the operation and decision making?
Okay. Let me connect this question also with the BIM implementation project that we are currently developing here in Enagás. So from the beginning, and also right now that we are defining all the BIM use cases, our goal has never been just to have a BIM aesthetic model, if not to reach a digital twin also connected with operation and maintenance. So to transfer a aesthetic BIM model into a digital twin, we need to connect and also to feed data with the model. So data on one side we have aesthetic data, so data from drawings or from design, dimension of the asset, of the object, equipment information. But also we need to connect also with real-time dynamic data directly coming from the field. So in order to measure the hydrogen flow in a pipeline, sensor that measuring pressure, temperature, energy consumption in a compression station, or also more simple data, but real-time data like status of a valve, open, close, or broken valve. So all these data are collected by systems like SCADA, and when you feed the model with this real-time data is when you stop having this being a static model and you reach a real-life system, okay, a real-life platform. So obviously here the next step is the creation about an asset control room with digital panels that you can see the entire hydrogen infrastructure in order to monitor several data like alarms, issues, hydrogen flow, and also the following next step of the maintenance of a specific asset. So I think that is very useful also for support the decision-making activities in real time. So to close the question, I think that the natural evolution of the BIM models are not just to digitalize a drawing, if not to reach a real-life system, always connected and ready for the works next.
Okay, thank you very much, Natalia. I'm going to ask you, Roger, and before the question I'm going to ask you, I would like to introduce a little bit because you are helping us, or you are participating actively from the Rovira I Virgili University in a research project that we are leading, and in which are all other institutions and companies working with us, which is green hydrogen pipes. This project aims to demonstrate how technically and also from an economical point of view it is viable to implement a green value chain of hydrogen. There are three big challenges in this project. The first one of these challenges, in fact, is an efficient production of hydrogen using proton exchange membranes for an electrolyzer. Also, another thing that is a big challenge for this project is how to store hydrogen using liquid organic hydrogen carriers. And the last one, and perhaps the most innovative that is in this project, is how to, or the process of injection of this hydrogen in high pressure networks. Okay, so it's in this part of the project, I think, in which we have more innovative solutions oriented as well to computational and fluid cycle. In which we are working on. And also it is interesting as well to understand that this project also has the approach of looking for couple sector and the coupling that we have with electricity, hydrogen and gas. So what I would like to ask you, Roger, in this sense and related with this real project, because it is a research project, but in the real world. No, I think it's a very intensive and a very powerful project. What do you think are the greatest solutions or digital solutions that can have more impact in hydrogen and also in sector coupling?
So indeed, we've been very happy to participate in this project in hydrogen pipes. It was a very ambitious project, as you said, because it goes from the generation of hydrogen using renewable energies to storage to distribution, and so the whole value chain, let's say, of hydrogen, right? And our part in there was precisely to build a large-scale digital twin for this system, right? So first of subsystems of these systems, and then try to couple them, right, which was the real challenge, right? So in building these digital twins, right, you were mentioning, right, that for some systems we can just use physical knowledge, or we can use blueprints or whatever, right? and that's fine. That's what we should do for systems that are very well controlled, that we've designed and we know how they work. But for this particular project, we wanted to integrate this with solar energy production, right? Electricity production, with gas demand or hydrogen demand at the other end of the chain. So physical models are not enough in there, right? When we want to build digital twins of this whole integrated system, let's say, or coupled system, we need some components that are well described by physical models, and that's all right. But when we want to couple them, we need something else, right? Because there are just too many things going on. And there we go to the other extreme of the modeling spectrum, and we try to use artificial intelligence, right? I think that's something that, well, it's in your phones, it's in your tablets, it's in our computers. We write proposals using artificial intelligence, we make drawings. So we also use artificial intelligence to build digital twins, right? But I think that what's really the take-home message from this, for our participation in this project, is that there is some middle ground that is very promising, and that's what I was thinking is probably the key technology that we should pay more attention in the future, and that is between this, in this spectrum of modeling, between physical models that are very well grounded on reality, we know what they are doing, we know the physics. When we want to simulate flow on a pipe, we do CFD, and like we can do this with computers and so on. Between this, which is very expensive to get, right? Simulating a pipe with hydrogen is very expensive, it's slow, right? So between this end and the artificial intelligence black box thing that we are tending to go now, there is a middle ground in which we develop artificial intelligence models that are similar to the physical models, right? So I think that the key technology is trying to use artificial intelligence, but not to design black box algorithms that are unreliable when you ask them to extrapolate or things like this, but using artificial intelligence to build models or digital twins that are based on models that are similar to the physical models that we are used to using in science and engineering, right? And these are several advantages. So one of the advantages, as I said, when you ask artificial intelligence to extrapolate to new situations, that usually gives rise to trouble, right? So you ask a neural network with billions of parameters to predict something that it's never seen before, and you can get anything, basically anything, right? Another problem is that it doesn't give you an estimate of the plausibility of the predictions. So you ask ChatGPT, write something, it writes something, but you don't know if that's the most likely thing that should have written, or if there are other things that are equally appropriate to the context and so on. And the same happens when we model a system, right? And so I think this modeling uncertainty, and then the an ability to extrapolate and interpretability, these are key factors that we should be looking in new artificial intelligence technologies that help us to build models for, especially when we want to integrate things and couple some of these subsystems that on their own are relatively okay and easy to understand.
Okay, thank you very much. Very, very interesting, Roger. I'm going with you, Nina. Yeah, in your case, well, from Siemens' perspective and well, your large experience in different solutions that cover a lot of processes, because we were talking this morning about that, and well, it is true that, well, yesterday even we had a workshop with your company, and we could see, you know, that you have solutions almost for everything, as we were telling this morning. One of the things that I would like to ask you is about digital twins, okay? Because we were also talking that today we have to think that perhaps we are going to have digital assets, no? or native digital assets, instead of having physical one at the beginning, no? So in this way, I would like to know, in your experience, no, how you define truly a real operational digital twin, what kind of cases of use you identify that are more mature, no? Mm-hmm. And above all, in terms of sustainability, in terms of efficiency, and in terms of reduction of environmental impact. Okay.
Yes, super happy to. So first of all, I think we have a lot of parallels here, which is good to see, right? It's always good to fit together with academics. So very, very good. So first of all, at Siemens, we're obsessed with digital twins. And maybe to explain a little bit, because that's a lot of the confusion usually, we're not Siemens Energy, we're Siemens SA. So we've been one company, but now we're two companies, but still working very, very closely together. So we're not the ones actually producing electrolyzers. We do a lot of digital twins. For example, we have a huge sustainability portfolio. As you just said, sometimes it's a little confusing because we have all the solutions for, in the end, the smart building part, the factory part, and mobility. So these are the three things, just to explain a little bit what Siemens is doing. When it comes to digital twins, we already heard a couple of the points I wanted to make, but for us, and this is really our strategy also as Siemens on a headquarter level, it's important to connect the real and the digital world. So OT world and IT world. You already mentioned it, it's super important to understand what are the physical components behind, right? What are the physical reactions behind? How are the OT assets actually behaving? That's super interesting. And then you have to take it to, or super crucial to understand, and then you have to take it to the next level and actually connect it with the IT world, and then building all these cool technologies like digital twins. The second topic was already mentioned as well. You really need to achieve optimization through the whole value chain, so that is super crucial. Really starting with the process, with the engineering part, all the way to production, to maintenance, to operations. So for us, it's super crucial that you have this comprehensive understanding and that you really can see the big picture of how your infrastructure production looks like. And the third thing, you actually also mentioned it, is it's super important that you also have actionable insights that you generate from it, right? It's not like, it's nice if you can simulate the whole world and then you have like nice little pictures, but if you cannot get actionable real-time insights, real-time recommendations from the system, it doesn't provide you that much value, right? What we always try to, or what we like to speak about a lot, is this digital native hydrogen plant, we call it. So as said, Siemens does a lot of projects around the world in a lot of different verticals, and already a couple of years ago we came up with the digital native plant. We have a couple of them ourselves, which is always good, right, to test a little bit the technology in our own company. So we have one of them in China, we have another one in Erlangen, so very, very German. Yeah, we have this concept also for hydrogen plants now. So what is the idea? Again, really end-to-end over the whole value chain, have one digital twin, a lot of digital twins combined together, who can simulate really the whole value chain end-to-end. So you can really see you can look into your manufacturing processes, you can look into your maintenance processes, you can look into your commissioning processes, you can look into the transportation part of things, the delivery part of things. So this is like really one offering that we see a huge, or one solution that we see a huge value in, because this is really giving you the big picture. But there's obviously a lot of other kind of smaller use cases that also work super nicely. So for example, there's what we also offer as an energy digital twin. So what do you put in? You say, these are my decarbonization goals for this specific plant, for this value chain, and then it pretty much simulates in the end, okay, so what kind of renewables do you need? What is the best energy mix? What is the best energy sourcing? When do I buy energy? These kind of things can all be done within one simulation model. Then there is one transportation digital twin. We already heard a lot that transportation infrastructure, these huge pipes that we have, are very complex, are very expensive, and in the end, what you could do with a solution like a digital twin is really simulating the flow of the hydrogen, the flow of the water, whatever it is that you try to do, and then find out, where can I optimize this in the end? Where do I need pumps? Where I don't need them anymore? So it's a very comprehensive solution. And then, as you said, AI, we see this as a huge, future maker in the end, because it will take everything to the next level, right? We will be able to use even more data for our digital twins. We will be able to simulate even more scenarios, learn more and more in a more complex environment with all these changes that we saw in the beginning, more regulations coming up, more uncertainties coming up. you will be able to simulate all these scenarios and then in the end, hopefully take the best decision for the whole ecosystem and for the whole infrastructure.
Exactly. Thank you very much, Nina. Well, I think that, well, more or less we are reaching more or less the end of the session. I would like to ask you if you can share with the audience a headline, some sentences or messages that you would like in order to wrap up or summarize your vision and your perspective in your different profiles and experience. So in this case, we can start with you, Roger.
Well, so just to summarize what I've said, and I'm very happy to see that academia is not so far from the real world, right? Lots of common challenges and so on. But yeah, we have a major challenge which is urgent, right? It's not that we have all the time of the world to solve it. For this, we need computers, we need computation, we need digitalization, and so on. We need to go farther from just collecting data and pretending that that's doing the work, right? We have to use this data, build digital twins, build models, and so on. And then in terms of what directly affects me the most, right? I think we know a lot about physical models. We see artificial intelligence as a potential ally in the future, right? Or perhaps soon. And there is this middle ground of a new kind of artificial intelligence, interpretable, that gives you ideas about risks and about probabilities and so on, that extrapolates well and so on, that I think we need to explore more and put more resources into.
Okay, thank you. Nina?
Yes, for me it's digitalize as soon as possible, digitalize the whole value chain, but do it smart, have a plan, and have sustainability in mind all the steps on the way.
Great, thank you very much. That's a very good point. And Natalia?
Yes, for me, I would like to leave here the message that digitalization, technology, and also people are the key pillars to ensure a quality, safety, and also sustainability infrastructure in hydrogen throughout the entire life cycle of the assets. I mean, the engineering, construction, and also operation and maintenance. This is the message. Also, obviously, thank you to Enagás to inviting BIP and also me in this roundtable. It's a pleasure.
Okay, thank you very much. Well, I think that we have more or less covered all of the objectives that we had at the beginning of this roundtable. Listening to you, I think, well, I was sure, and it is a really privilege to have you here. And just to sum up, I can see that we have seen that digitalization, in a nutshell, is not just a tool. I think that we can think that it is a real structural lever that can change hydrogen infrastructure in the sense of resilient, more efficient, and sustainable. No, is one of the main things that have appeared here in the table. And I think that for achieve this, and is one of the things that I caught in your messages, is that we have to connect data, we have to connect people, and we have to connect decisions. So thank you very much for your participation. It has been a big pleasure.
Thanks to you.
Thank you.
Okay. Thank you, the moderator and the rest of the panelists. It has been a very insightful session. Now we will have a coffee break of 25 minutes, I think. At 11:30 we will be here again. So to those who are following us on streaming, we will be here at 11:30. Thank you very much. 11:30. Sí. Bueno, no lo sé. Bueno, yo lo que digo es que luego se puedan enrollar, ¿eh? Porque la de Claudio se va a enrollar. Entonces, mi consejo es, si queréis acabar en hora,
Vale, simplemente por comentar,
sí.
tenemos que lanzar un audio de aviso para que la gente vaya viniendo y demás, entonces la idea es que ya tú recuperarás desde
Sí, yo me pongo
aquí
ahí.
directamente, o sea, no te vemos subir
No,
como en esas
tranquilo.
ocasiones,
Sí,
¿vale?
sí. Pero no sé, lo de arrancar ahora, bueno, en fin.
Pues ahora le comento a María que nos dé ya...
No lo sé, lo digo por el tiempo y eso. ¿No, Arturo? Sí. Claro, dilo ya, sí, porque yo creo decía y 35, no, ya. Y ya está. ¿La mesa cómo se llama? Sí. ¿Arranco? No, espera. Hi. We are waiting 1 minute because the streaming, we have told to the ones that are following us on streaming that we start
in 30 minutes, 11:35. So 1 minute remaining. Okay, so let's start again with the next roundtable. We hope you have enjoyed the coffee break. And now we continue with the next interesting roundtable. The role of the original equipment manufacturers to build a European hydrogen network. The role of the original equipment manufacturer is key for the energy transition. Developing innovative technologies and efficient catalysts that make it possible for the production, transmission, storage, distribution, and end use of green hydrogen. So please, a warm welcome to the next roundtable that will be moderated by the Director of Technical Services and Technology, Pedro Rubio. Please come to the stage with the rest of the panelists. Thank you very much.
Good morning, everyone. It's a pleasure to welcome you to this roundtable focused on the critical role that the OEM are going to have in development a network, efficient, robust, and interconnected hydrogen European network. We are at a pivotal moment. The European Commission has placed hydrogen infrastructures at the heart of its strategy to achieve an energy independence, industrial competitiveness, and climate neutrality. In this context, the role of the original equipment manufacturers is going to be more than a technology provider. It's going to be a critical strategic partner in reshaping this energy system. Today, we are joined by representatives of 5 companies leading this transformation. Each of them contributes to a vital piece of the puzzle, which together we are assembling. Thank you for joining us to this roundtable, and let's begin with Dr. Holger, representing Mannesmann Line Pipe. Holger is a mechanical engineer with over 25 years of experience in material science, innovation, and quality assurance, leading research and development initiative at Mannesmann Line Pipe since 2007. He brings deep expertise from both industry and academia, including roles at ITER AG and the University of Essen. His work bridges cutting-edge research and industrial application on steel and pipe sectors. Good morning, Olga.
Hello.
At what stage of technological maturity is your hydrogen pipeline technology, specifically in terms of its current development stage, technological capabilities, and scalable production capacity?
Thanks, Pedro, for the first short introduction, and warm welcome from me. And first of all, a big thanks to Enagás to have the opportunity to speak here for us and for me. We as Mannesmann Line Pipe work in the field of hydrogen technology for more than 15 years. Started 15 years ago, and now are ready with our Mannesmann H2 Ready pipes in all the dimensions we offer, from 4-inch to 24-inch, all the wall thickness up to 1 inch, all the material grades that are typical for the pipeline industry, and together with our sister companies, Mannesmann sister companies, I'm also ready to to deliver pipes up to 64-inch in the whole Salzgitter group. And this is and we have one advantage is for our pipes, for our hydrogen pipes, is that we have the whole production route located in Germany, starting from the steel making process, and this gives us the opportunity to have a close collaboration with our material suppliers to work in the field of material development. And coming to this, we have to look at the requirements that are needed for H2 pipes. So we work on close collaborations with our with the pipeline operators. Look at the bilateral, or in the case of the European Pipeline Research Group, we look at the requirements in standards, and also develop requirements further on, and also work in hydrogen standardization to advance, to optimize the requirements. And of course, all above, we qualify our pipes according to these standards, do a lot of hydrogen tests, slow strain tests, K1H test, JR test, and so on, and share these results with the customers in publications and whatever, so that the customer knows what he will get if he orders a pipe from Mannesmann, from Mannesmann line pipe. But all this is in a changing, more or less a changing process. Requirements are changing, the tests, how to carry out the tests are changing. And there are several unsolved questions, like how to deal with tests during the production, because the hydrogen tests, they last a long time, and normally the customers don't have this time from the production of the pipes to the delivery of the pipes, and also looking not only at the pipe infrastructure, but also at hydrogen storage, because during winter times, if it's dark, if there's no wind, you need these storages like caverns, and they have demanding requirements like 250 bars or above. They have humidity in the gas. There is hydrogen sulfur maybe in the gas, and this has not been fully tested or anchored in the standards. And this is also something we are working on. And but in the end, we are ready to assist the projects of our customers. And now the customers need, so the pipeline operators need the security of in several questions to build a reliable pipeline infrastructure, like the financial aspects, like the political willing, the political authorization, and so on.
Mm-hmm. Thank you, Holger, for the contribution. So our next guest is Ms. Vauhini Telikapalli, representing Burkhardt Compression. So it's a privilege to introduce a pioneering leader in the global transition to sustainable energy. With over 3 decades of experience in the energy, chemical, and automotive sectors in US and Europe, Vauhini has dedicated her career to advancing innovative and impactful technologies. In her current role as Business Development Manager for Hydrogen Mobility and Energy at Burkhardt Compression, she is at the forefront of shaping the hydrogen economy. Beyond her corporate role, she is a global speaker of one of the most critical topics of our time, the energy transition. So, hi, Vauhini. From your perspective, what are the most significant factors influencing the maturity and deployment of hydrogen compression technologies in the context of the European hydrogen backbone?
Thank you, Pedro. On behalf of Burkhardt, I'd like to personally thank Enagás for inviting us. It's an honor and a privilege to be here and to be sharing the panel with some esteemed panelists here. Burkhardt Compression, we create leading compressor systems, in particular for the European hydrogen backbone. We are devoted towards creating a sustainable energy future. In my view, there are some key factors which are interrelated, in particular for the deployment of mature compression technologies, keeping in mind the European hydrogen backbone. Number one is technology is key, performance is key. When we look at compression systems, we are looking at large quantities and volumes of hydrogen gas that has to be handled at elevated pressures of 100 bar and beyond, depending upon what the pipeline segment is. Number two, also that we have to keep in mind is the reliability of these compressor systems. Because when we try to integrate, in particular with cross-border infrastructure, the requirements are a little different, varies between one country to the other. So that's another point that we need to keep in mind. And the third point is maintenance. There are certain areas which might be remote and might require to go there and maintain. So the mature compressor systems have to be adaptable, have to be flexible, so they can incorporate all this. Burckhardt Compression, for the past 50 years, we have experience in hydrogen compression. We've got credible references on the field, and we have a lot of field service engineers who are very good at what they do in terms of maintaining our compression systems. The second most important point is also the choice of materials that are used for designing and manufacturing the compression systems. We're all very familiar with the embrittlement of hydrogen, which is a known challenge. There's a lot of development that is happening also in coatings, in sealing systems, in composite systems. That's good for long-term durability, but we still have a little bit of ways to go, especially at elevated pressures at 900 bar and beyond for the mobility applications. The thing that differentiates Burckhardt is that we are an R&D company. We dedicate a lot of time on innovation. We have our own in-house materials, the persister material, and also the state-of-the-art Redura sealing systems. So it's important to have durability of these wear and tear parts for a longer duration of time, because these compressors are on the field for 40, 50 years and beyond. So it's important to have not only the technology part, but also the material part that needs to be. I think the third and most important is the integration of the compressor systems into the European hydrogen backbone. Because I think most of us know that till 2035, probably there'll be a lot of repurposed natural gas pipelines. So our compressor systems have to be adaptable, have to be flexible to incorporate not only the natural gas, but then also be adapted when the technical requirements for hydrogen come in play. We have developed a solution around that because we have a containerized system, primarily for high-pressure mobility applications, where you have the compressor, the auxiliaries, the motor, all that in a container, and it's very easy to deploy it. It takes only a day to install it on site. So that's another thing that we bring in, is mainly the integration. How do you integrate the compressors into the European hydrogen backbone? One of the things that was talked about in the morning was the uncertainty about the regulations, the operating protocols for hydrogen compressors, the safety certifications. I know Europe, especially the 28 member states, they're trying to harmonize that. But Pedro, that becomes one of the challenges for the OEMs, is like, if we know the scale, then we are able to plan and manufacture those. So, but we are already ahead of the curve, and we are looking at these containerized solutions that we will be deploying if the opportunity arises. Last but not the least, it's always the total cost of ownership for hydrogen, in particular from the production to the transportation to the end use. And I know investors are looking at de-risking. How do we de-risk projects? Market mechanisms, subsidies. But I think, in my view, it is probably going to be the long-term offtake agreements which will propel the hydrogen market at scale. So in closing, I believe hydrogen is that beacon of hope for energy transition, and it's a key driver to bringing our CO2 emissions down. And Burckhardt is there all the step of the way for the European hydrogen backbone. We'd like to participate in that. Thank you for the opportunity.
Thank you, Vauhini. So let's jump to our next guest, Dr. Olga Kotkowska, representing Endreshauser. Olga holds a PhD in chemistry from the Universidad Autónoma de Barcelona and is leading expert in renewable energy innovation. With extensive experience in industrial automation and process optimization, Olga currently leads the development of advanced measurement technologies at Endreshauser, focusing on green hydrogen, production and distribution. Her work helping industries transition toward cleaner and more efficient energy system. What are the main challenges faced by a leading company of industrial process measurement and automated process?
Okay, thank you very much. Thank you for the introduction, Pedro, and thank you for having in mind Endreshauser and inviting us to take part in this roundtable. So yes, the first challenge would be, of course, cost. It's the first thing that comes to our mind. I think that all of us that work in here, our goal is to make hydrogen affordable, make it competitive, comparing to the counterparts of the fossil ways. So the situation right now, I think, at the market is like European market. It's around 3 to 8 euro for green hydrogen, depending on the technology, whereas the fossil, so the crude oil, is 1.5 to 2 euros. So there is a huge price gap. And what we have observed is that developers are challenged by this price gap. However, very surprisingly, when we enter the project, there is a certain tendency to over-instrument the projects. So everyone gets very excited because those projects, you know, they are very fancy, they are very well known, and everyone just wants to do it well. And that's fine, that's great. But sometimes we just have to go back and you know, concentrate on what's important. So my advice would be to really know which points that you are going to measure are really important and which ones are maybe less important. So choose the best technology for the right point. Company like ours, we have a big variety of instrumentation, and we can provide right instrumentation for the right point, so there is no problem in it, but be sure that you have identified those crucial points. For example, at the end of the electrolyzer, after the purifier, where you have to monitor the quality of the hydrogen, so you have to basically measure oxygen and humidity because there is nothing else. At very low levels, so be sure to put good analyzer there, go for a laser analyzer. They are in the industry for years, they are well known, then you even gain on the maintenance in the future. Another point would be custody transfer, where you know you really have to have a good measurement there because it's money. So go for Coriolis flow meter if the pressure allows you, of course. Don't gamble in the points that are important. Then the second challenge probably would be the molecule itself. We all know that hydrogen is very challenging, small molecule, very volatile. It can easily permeate the materials, and you work on extreme conditions, so very high pressure or very low pressure. Recently, we have received a lot of requests of one of those challenging points. So it's at the end of the electrolyzer where you really want to be sure that what the provider of the electrolyzer is telling you, that is providing you, is true. So depending on the electrolyzer, it can be very challenging. You can be at very low pressure, sometimes atmospheric, and then you have very high nominal diameter, and it's really hard to measure that. So when we have those requests, it's nice because it kind of makes you, you know, to regroup, to go back, look at your instrumentation that you know for decades, that works well, and how to use it in this extreme condition. You go back to your production site, speak with your expert, just to be sure that you are providing the right solution for the client that will work for them. So the third one, I think that it would be the regulations. This is something that we are all aware of. There is a big lack of regulation for hydrogen, a standardized one, and only for hydrogen. We have recently joined, we are participating in a project of Iberdrola and BP in Castellón. So you know that they have a joint venture, very nice project. I think that the biggest one in Spain now, electrolyzer of 25 megawatts. Of course, the source of electricity is renewable. The goal is to provide 2,800 tons a year, more or less. So a lot of green energy, and the goal is to substitute the gray hydrogen with the green hydrogen. So in order to be more sustainable. Very beautiful project. We are very happy to participate in it. But even when you sit with people that work for a long time in this market, we still have these discussions of which regulation to choose, because you have the regulation that exists in the market and it was not created for the hydrogen. So you have MIDs, you have OIML, horrible to pronounce, and you have to choose there you have free options, and you are in a discussion with your client, which one to apply and which one is better, knowing that even if you choose, it's not perfect, it was not created for hydrogen. So I think that there is a big gap that we have to work on, because we need to care about safety and traceability of the hydrogen. So I think that we should really sit together, all the people from the value chain, and work on that, because it creates delays, it can create additional cost, and it is not necessary. It is just a matter of working on that. So I think that those three challenges are the ones that we deal with them daily. Then you have digitalization, but I think that I'm running out of time, and it was discussed before, but yet there is a lot of work, because you have instrumentation of different digital maturity, how to integrate it together. It can be a challenge, better. It can be very hard. So I think that a lot of them, but still, let's be positive, they can be sorted out.
Very interesting, Olga. It's very interesting, you mentioned. Our upcoming guest is Mr. Federico Ricotti, representing SLV Valves. Federico holds a bachelor's degree in mechanical engineering from the University of Pavia and a master's degree from Politecnico of Milan. Since 2016, he has been valve engineering manager at the Grove facility. In this role, he oversees the design of valves and equipment, and is responsible for all Grove products and the rest of the facility worldwide. One of his recent achievements is a new patent recognition as an inventor for an innovative valve concept, providing superior isolation and safety for operators. So what are the main challenges in designing and manufacturing valves for hydrogen service, and what experience does your company have in this field?
Thank you for the question, Pedro. First of all, I would like to thank Enagás for the invitation here. Very proud to be here and discuss with all of you about this matter. Time is running, it's brutal countdown there, so we can talk 1 week or more about hydrogen and valves, but to reply to your question about the main challenges, we have to say that even if we know, and some of you guys already mentioned some of the challenges, we not invent a new wheel. So we start from proven in use technology, to have a solid background of a valve installed in several applications, from very challenging one containing H2S, and also leveraging on our history. Our Cameron SLB valve exists since 100 years or more, and the facility where I'm sitting in founded in 1971, so more than 54 years of experience in different applications. We are making valve from 1 inches, 20 kilograms to 64 inches and more, so 100 tons. And of course, each single design of valve have a different challenge. Okay, from low pressure class 150, you talk about low pressure versus high pressure. The challenges are different. And so from 150 class 19 bar to 15K PSI, so 1000 bar or more. We are expecting that the major infrastructure of hydrogen pipeline will be around 600 class, 100 bar, and 900 class, maximum 1500 class. So starting with the legacy design, And we group all the subject matter experts of my team and also other experts around the globe in our company to look at what is existing, what is working, and implementing, what I like to say, minor modification to accommodate hydrogen. We have valve installed in hydrogen service since decade, like we have valve installed in ammonia. This morning we talk about ammonia as a potential vector of hydrogen. Our old record of valve in hydrogen and ammonia belong to 1983, well before the current fashion and rush to have valve hydrogen ready. So starting from that, it's true that there was a lack of code, industrial standard, and I talk in a minute about this. Secondly, our company is working a lot in R&D, and before going to the market with a nice fancy statement, hydrogen-ready valve, we have done all the due diligence to test and prove that the material, not only metallic, but as well non-metallic material, have been tested before putting the valve in service, leveraging, as said, the previous experience. The majority of the valve we supply for hydrogen service in the past were for refinery and process application. Now, the need is for gas pipeline application. The program of testing in our company was very extensive. We started some years back. I was deeply involved in testing of metallic material. We talk about embrittlement, ductility of the material, cracking, propagation, and literature was already having a good background on the metal part, not so much in terms of non-metallic material. I started working as a valve leader in 2008, 17 years ago. And when talking about elastomer, rubber, and thermoplastic material, gasket sealing were considered a minor item. Now, no more. If there is a failure of a gasket in a valve, could result in a catastrophic happening, and so we have to avoid this. So no more called minor item, and these items were subjected to extensive testing. Problem is that when we started, there was not a guideline. There was nothing written how to test gasket material in hydrogen. So I group again my team, and all the brain come up with a draft of a protocol for testing seals and materials in hydrogen. We start from well-consolidated NORSOC M710 with modification to accommodate the testing in hydrogen. And what we look for? We checked for a rapid gas decompression issue, which is also happening in natural gas or methane, but hydrogen is a small molecule, so our testing was about to look at what is the difference between methane mixed with H2S, for example, and hydrogen. So we did an extensive testing on hydrogen 100%, like we did 100% CO2 and in ammonia, to prove the gaskets are good and not suffering any failure. Then we did the permeability test, and then we did also aging test, comparing the result with the previous test already done. Coming up at the end with a major takeaway, if the seals are already qualified for 100% of CO2, are also good for 100% hydrogen. So CO2 attack is more than hydrogen, okay? But we are not just tested and qualified metallic material and not metallic material, but well before the current fashion, we were starting testing the valve in our factory, in our laboratory testing department. Of course, in the factory, we cannot use hydrogen for safety reason. So we have tested the valve using 100% helium. Helium, as you know, is a small molecule, and so represent very well what can happen with hydrogen. Qualification was done first for emission to atmosphere. So a lot of money was spent to qualify a majority of our valve. We have many valve type, ball valve, gate valve, check valve, swing check, side entry, top entry, fully welded. And so our qualification was to avoid any leakage to atmosphere. Then we tested also through bore leakage, seat to ball. Many valve tested with water, A lot of valves tested with nitrogen high pressure. But in order to represent the leak we can obtain with hydrogen, we also use helium there, seed to ball. The results were very good. Then, since there was one of the main challenges was the lack of code, I was assigned to be member of the task group of API 6D, developing and initiating Annex M. In the committee, there were not only valve maker, also our friend competitors, but also operators, final client, and also subject matter expert, metallurgist for metal part, but also supplier of gasket, sealing element, etc. All the brain share the idea and their knowledge, and I think we obtain a very good result. So Annex M is now incorporated and published as Addendum 2 of P6D 25th edition. This is the first milestone for having a valve maker and also in general other product maker a guideline to test and qualify the valve in hydrogen service. It was a very good result. And also a very long journey because we started 2 years back. We talk about valve testing, quality requirement, etc. And another challenge is cost. There is different hydrogen specification level in this Annex M from 1 to 4 to avoid overspec all the time. Everyone would like to have the valve perfectly suitable for all the conditions, high pressure, high temperature, blow down, but there is also a matter about risk perception. Hydrogen specification level 1 is the less demanding one. Hydrogen specification level 4 is the most demanding one, because you can understand easily that the risk associated with the valve or product running hydrogen is very different if the valve is in a pipeline in the middle of the desert, in the middle of the jungle, or close by building, residential houses, etc. So final user can select different hydrogen specification level and increase the quality check and the testing requirement and validation to have at the end a very safe and reliable product.
Thank you very much. Very, very interesting, Federico. Our last speaker is Marco Baldini, representing Baker Hughes. Marco graduated in industrial engineering from the University of Rome. He works as a hydrogen solution architect for gas turbines and systems in the Climate Technology Solutions Organization in Baker Hughes since 2002. He's supporting worldwide energy companies in the early engagement phases, evaluating viable solutions toward net zero emissions. He develops tailor-made feasibility studies and business cases with the customer's viewpoint and impacts in mind. At what stage of technological maturity is Baker Hughes hydrogen-fueled gas turbine technology, and if there are any further development in place? Marco.
Thank you, Pedro, and thanks to Enagás, to the people that are connected in streaming, the people that are in this room. It's really a pleasure to be part of this panel session. We can say that Baker Hughes is driving the hydrogen revolution, starting from its legacy and experience, having more than 30 years of experience in burning high hydrogen content, more than 70 units running worldwide, but also we have 15 years that we realized the first gas turbine able to burn 100% of hydrogen. I'm thrilled to be here today to show a gas turbine that could change the world for better. Novelty 16 is a 16 megawatt gas turbine able to burn 100% of hydrogen today, and is able to keep the NOx emission low down to 25 ppm, having a selective catalytic reduction system at exhaust. This machine is the unique machine in the world able to start up on hydrogen. This is a perfect fit for a green hydrogen production plant, and this gives the opportunity also to be evaluated in the mechanical drive application. Furthermore, this machine is able to switch on the fly between natural gas and methane, and this gives a strong reliability on these units and for the operator that can have the same performance. Last but not the least, we are offering the same maintenance plan of natural gas, 35-70 kWh, with a fast engine swap. This means that this gives a lot of availability of the machine. Our gas turbine is not a prototype, has been tested at CESTA Lab in 2022. We defined the challenge on the combustion system, and we have performed an extensive test campaign from December 2023 to March 2024 to verify all the parameters, the NOx emission, the performance, to have a smooth operation. This is important in order to have a machine that is ready for the market and for our customer. We already sold units for a blue hydrogen project in Canada, thanks to the cooperation with their products. And as someone said this morning, it's really important to cooperate with our customer to reach this great milestone to burn hydrogen in our gas turbines and to have hydrogen available to reduce the CO2 emission. We are going to, we can use this gas turbine in power gen, combined cycle, in cogeneration, but also in mechanical drive application. And this could be a great driver for the European hydrogen backbone. Considering the impact of and the increase of renewables, we need to have a system that is really flexible, and dispatchable thermal turbines are really the key in order to have a reliable grid, because can have special application like load following, peaker as backup. So there are many applications, but also can be considered also a great solution in order to have energy demands for long term. Our gas turbines is also has also the possibility to burn 100% of hydrogen having low NOx emission. We are working with some partners like Equinor, Snam, to mention a few, and is also part of the European Union funded program. It's called iPower GT, where we are going to have a combustor that will be tested this winter in the CESTA Lab facility in Tuscany, where we are going to reach less than 25 ppm without having any catalyst or diluent. This will have a great possibility to deliver this product and test again the entire system in our hydrogen village in Florence. It's worth to say a couple of words on this hydrogen village. We built this hydrogen village 2.5 tons of storage in order to have the possibility to perform this gas turbines test. And this is great because we learned a lot. We understood what was the improvement that was needed for the package, for the gas turbines, for the combustor. And we also received a third-party approval from TUV South according to the readiness at 100% of hydrogen. So our product is ready, and we are continuing to invest on it, having the product with full DLN available for the next year.
Thank you very much,
Thank
Marco.
you,
We have some minutes more, so I would like just to be kind enough to share a final message regarding the maturity of your technology and your companies. Starting with you, for instance, Vauhini.
Yeah. Thank you again, Pedro. In my view, I think there are three key factors. One is there needs to be collaboration between all the ecosystem players along the value chain, because each of us brings our strength, and if we are all able to collaborate together, that's point number one. Point number two is the mismatch between the production side and the demand side. And if there is more certainty on the long-term offtake agreements, that will help pick up the demand side. And then, the production and the demand side would be in sync. And I think the last point is also for companies like Burkhard, where we are, ready to scale up and deploy at scale. That comes with certainty. The market certainty, which is also the cost uncertainty that Olga has also mentioned, but also the harmonization about what certifications are needed for hydrogen compression. What are some of the policies and regulations? If that could be a little bit more clear, it would help companies like ours to deploy at scale, because that brings the cost down. So those are the three key messages.
Thank you, Vauhini. Marco, would you?
Thank you again, Pedro. I believe that I like the sentence that we heard before. No, hydrogen is now and we have climate technology solution to fully decarbonize today. This is really important because I believe our partner, not our customer, our partner needs to understand what are the bricks that are missing, but starting to build for what is ready. And we have climate technology solution to support our customer. And I fully agree with Vauhini. It's important also to cooperate with our, in the entire value chain where we can understand what are the challenges, and we can also cooperate with our, with the other OEM to have a hydrogen value chain that is sustainable for our customer.
Thank you. Thank you, Marco. Holger, could you share some?
Thanks again. From my point of view, I think what we heard already, there are several questions to be answered in the future, like where's the hydrogen coming from? Where is it going to? What is the application? What is the hydrogen? Is it with pure hydrogen? Is it a blend, 10%, 20%? And there are several more questions to be answered. And I think what we all have together in common is that we want to be the egg, or are we the chicken? You can decide for yourself. So we have to be. We want to be ready before the hydrogen is needed. It's really, really needed. We have to be ready, and it's very important to talk together, to have regulations, to have requirements ready that are needed in the future to build a safe and reliable, and from the cost point of also, of course, infrastructure for hydrogen transport and storage.
Thank you, Holger. Olga, your turn.
Thank you very much. So from our perspective, so the perspective of the technology provider, I feel that when we enter a project, there's still some uncertainty. There are still some points that we are not sure, so we have to be patient to work on that. There is part of the work that depends only on us, so we have to work with our technology, be sure that the solution that we are providing is the right one that our client and the application needs. But then there are still a lot of factors that we don't have influence, and it affects a lot the project. So we have mentioned the regulation, and I do agree with Vauhini that we really have to work together to create one that would be standardized, that would enclose all types of projects, and so that you don't lose time and you don't lose this pressure money that we need to make the project affordable on things that can be avoided. So yeah.
Thank you, Olga. Federico, your last minute.
Let's see the count. Okay. In terms of maturity, I would like to say that in a fair way, our products are having a very good technical readiness level. Because we start ahead of time and testing, and because the result we got are very satisfactory and can provide to operator confidence that the product is good and will last for a long period of time. If I forgot to say in the previous speech that if someone is interested to see our result, of course, we cannot disclose all details, but there is a good article that is being published by two of my colleagues, one French guy, one based in the US, in the Valve World magazine. The article is on December 2024, so very easy to look at it and take a look at what we have done.
Okay, thank you. Thank you for your insightful contributions today. We have covered significant ground and highlighted the critical role that OEMs play in building a robust and interconnected network. So let's continue to collaborate and innovate to achieve our shared goals, and I hope that all of you have a great day. Thank you.
Sí. Okay. Thank you very much to all the original equipment manufacturers for their insights. What is clear for me is that the technology is at the commercial stage. There are issues to be tackled and improved in order to obviously reduce the cost of these equipments, but we are here. Now we have, they are putting their microphones, okay? But the next roundtable that will be moderated by our gas general asset manager, Claudio Rodriguez, and he is as well the chairman of the H2GAR initiative. He will be the one that will moderate this roundtable that is called Ensuring Integrity of Midstream Hydrogen Infrastructure. So as soon as you have the microphones with you, please come to the stage. Claudio and the rest of the panelists. Thank you very much.
Good morning, everyone. Meanwhile, we're finished of preparing the rest of the speakers. I introduce the H2GAR project. From the beginning of, I don't know if we have the presentation. No. Wait. From the beginning of 2020, 7 TSOs, SNAND, Natran, National Gas Transmission, OGE, Gasuni, Fluxys, and Enagás launched a so-collaborative project focusing on the development of technical regulation, technologies, and especially practical guides for the development of the new hydrogen midstream. Obviously, the challenge was great, so we decided to establish a preliminary gap analysis where we compare where the state of the art was and who was going what. We analyzed where the technologies, where the OEMs at the previous roundtable, in order to determine the priorities of collaboration on the projects of push specific knowledge, niches of specific development. We have a clear focus on the whole life cycle of the assets, from the blending to the pure hydrogen, from repurposing to new designs. And in 2022, 2 years after, and just because of the repowered position in the corridors, we have cleared that the purpose of the project was a good initiative. Because these corridors require a common understanding of technical aspects, technical procedures for the design and the future operation and maintenance. Currently, we are 16 members. From TSOs, the whole of us, and then converting HTNOs, and for have a clear idea of who we represent, we are close to 55% of the kilometers and 40% of the investment budget of the current hydrogen infrastructure PCI list. Obviously, we are in a moment of change. We are managing the whole project in 6 working groups in order to cover all the technical aspects of the different requirements of the hydrogen midstream. But now, after 5 years of development, we have cleared that the future is in 2030. In the early 30s, all the TSOs, the future ATNOs, are going to put in under operation, in commercial operation, our portfolio of assets. So it's a moment to implement new requirements, to review the initial gap analysis, and perhaps introduce concepts that operation and maintenance in order to be sure that just at the beginning of the first molecule will be under operation, will be ready for being safety and cost effective. So it's the moment to share the knowledge, to share the floor to the real experts, the leaders of any of these working groups. So I am going to introduce shortly any of them. Ivan Montero is the representative of the working group 1, pipeline. He is the equipment and materials expert of Enagás. The second expert and leader is Franco Bagnier. He is a compressor station expert from Natran. The third, the representative of separation system, is Marco Tarensi, that is power and control system manager of SNAM. The fourth is Jose Pepelana, that is the innovation engineer of Enagás, as is the representative of the metering working group. The fourth is Natalia Barbieri, is an environmental engineer of SNAM, it is the representative of the underground storage group. And finally, Lisa Witty, that is a senior engineer from National Gas Transmission and is the representative of the most transversal group, that is safety. So, after this introduction, the first question is clear. After 5 years of developing, what has been the main achievements, the main goals in any of your working groups? Ivan.
Thank you, Claudio. Well, hello. Over the past 5 years, the working group 1 was focusing on understanding and addressing the potential impact of hydrogen in the transportation of pure hydrogen or blending of hydrogen in the infrastructure, both in new pipelines and in existing ones. We started with a gap analysis and a technical assessment of the infrastructures and identifying the specific impact of hydrogen. We know that regarding the materials, the hydrogen impact in the reduction of the fracture toughness, the increase of the fatigue flow rate, and the reduction of ductility. Apart from this, we established the main focus and the main goals of the group, just to clarify what are the main requirements that shall be applied for the new infrastructures and for the reconversion of existing ones. Not also for the materials, but also for the integrity assessment methods. Another important activity was related to the technical framework. We started with the only international standard recognized that was some years ago, that was the ASME code. But we know that this standard was very conservative. And for this reason, all the members promoted a revision of the European standard. And in fact, this standard has been reviewed during the last year. Last week was submitted for a formal approval, the new amendment of the standard. And this standard is important because it's for application in Europe and includes specific requirements for hydrogen transportation and for the repurposing. And another important activity of the group is, of course, the sharing the knowledge and sharing also the testing campaigns and all the information that we have been collected each one. And of course, aligning our efforts in another technical working groups like EPRG, on which we are involved for the next steps. That was more or less the main activities on which working group 1 has been involved in the past 5 years.
Thank you, Ivan. Francis, what about compressor stations?
Thank you. So the first question has been in the group, which technology that we can use to compress hydrogen, and especially for our business as TSO, it's with very high flow. So we ask manufacturer to have this information, and we have seen that centrifugal compressor that is very comfortable for high flow has been ready for many years, and the first one that we have found has been in operation since 1915. So it's a long time ago. And for turbines also, that we have seen that turbines are also operate hydrogen for many years. So after that, we are very confident in this technology. That we have seen that there's also some difficulties and very high capex to use this equipment, because centrifugal compressors has limited in pressure ratio, and turbines also has conventional combustion system with emission. So the idea is to improve this technology in the future to reduce the cost with equipment, with less material, and also with reducing the footprint of this equipment. So we have seen that there's some new development, and so especially with pressure ratio, with centrifugal compressor, with new design, with high speed, and also new materials, so new design and new materials to reduce, to increase the ratio in this. And for turbines, also there's some improvement in DLE, so in dry low emission, so to have no additional equipment to reduce the footprint, so to avoid to add some equipment, so to reduce the footprint, the cost, and also with less equipment to wash the smoke, you also increase the efficiency. So we expect, so in the last 2 or 3 years, we have seen that there are a lot of improvement in both technology from the manufacturers. So we are very confident in the future. And in a case, yes, we have the former or the current technology to use in case.
Thank you, Francis. Marco, what about these so particular elements that are the separation systems?
First of all, allow me to explain why I have
yes.
the only tie here, because there is no sponsor, hydrogen, only for this. So that one. Coming back to the real question, the approach was, if I have to separate hydrogen from other gases, what is commercially ready, the tool that I can use? So the working group, first of all, decided to have a study of the tool. And the membranes, polymeric membranes, were focused as a commercial solution. The second is we have different scenarios. Someone sometimes says, okay, we have a new energy vectors like mixture between hydrogen and natural gas. Then someone say, no, only hydrogen. But I have this kind of solution ready for this scenario, yes. And membranes that are in TRL 9, so commercially speaking, you can buy them. But this solution is for other processes. So working group 3 contacted the suppliers, gave case studies, and they say, yes, if you need to separate hydrogen, for example, in a methanocentric perspective, so you have to preserve the end user that don't need hydrogen, and hydrogen can't be in the mixture. For example, the automotive fuel station that can, in Italy, be connected directly to the network, but you can't send hydrogen, you have this tool. Otherwise, you can have this tool even for other needs. For example, and we can speak after, if you are thinking to store hydrogen. But our working group is studying what are other solutions with the lower TRL. For example, the electrochemical separation systems. Or we have a look to cryogenic or pressure swing adsorption system. In this way, we are monitoring what is the development in the world, and we are focusing in use the right tool for our needs.
Thank you, Marco. Pepe, what about measurement systems?
Hey, good morning, everybody. Well, when we started 5 years ago to work about metering in H2CAR collaboration, well, we see that hydrogen is not new in the market. Hydrogen has been in the market for more than one century. What is new is what we look in the future. We want to build a hydrogen economy for the energy transition. That means that in the past, hydrogen was an industrial gas, and now we want to treat it like a fuel gas, for instance, like is the case of natural gas. That means that the needs for metering are different. So the first things that we have was to look to the state of art, and for doing that, we investigate on internet, and mainly we contact the OEMs to know what product they have ready for hydrogen, what was his development, what are the challenges for doing this, and we know that technology is there. What is not is perhaps is the regulation and the certification of this equipment. Another important point during this time in regarding metering is that most of our companies are already involved at this stage in pilot projects regarding hydrogen. So we made a knowledge sharing about what is the solution that each of us was using in these pilot projects, using the available technology and our best engineering practices. That was also being very useful. This ended last year in a common approach about hydrogen metering. We produced a document that is available in the website of the Hydrogen Observatory Technology, in which we propose how to measure the big amount of hydrogen that is expected in our networks, while there is not the right regulation and guidelines for doing that. Because there are many technologies there, but not at this moment has the, we can say, the certificates needed for a physical metering that is something that will be needed in the future for the utilization of hydrogen like an energy gas.
Thank you, Pepe. Donatella, especially in a green hydrogen scenario, the presence of underground storage is determinant for balance and for equilibrate and be sure that all works properly from the integrity point of view. What are the advances of your group?
As you said before, Claudio, I am the deputy of the working group number 6, completely dedicated to underground storage of hydrogen. During this year, the working group worked bringing together all the perspective, the expertise and information from each member in order to have a comprehensive overview of what are the challenges connected with hydrogen injection into underground. We focused mostly on depleted fields, porous media, and salt cavern because these are the kind of storage that the companies are dealing with. I try to summarize what are the main challenges because hydrogen storage comes with several challenges because of the unicity of the molecule. It is a small molecule, very reactive and can react with fluids, with rocks, with other gases, and understanding how reaction take place in the surrounding of the underground is crucial to guarantee a long-term survival, integrity, and safety of the underground itself. So we found out, according to studies, that one of the most important challenge in underground storage of hydrogen is microbiological risk. In natural environment exist different bacteria and archaea that can act as catalysts for geochemical reaction that otherwise would be very, very slow and can lead to the consume of hydrogen and production of byproducts such as hydrogen sulfide, acetate, CO2, methane. It depends from what kind of bacteria do you have. And this phenomenon can alter gas quality, gas composition, and alter pH of the formation fluid, and might also lead to modification in permeability and porosity of the reservoir. And that's why this phenomenon must be deeply investigated on a site-specific base, of course. Regarding diffusion and integrity of the reservoir, let's say that this phenomenon is considered manageable because diffusion is the phenomenon that occurs in the cap rock. The cap rock is the rock that contains the gas and is made up clays or salt, depend from the formation. And it has been demonstrated that the diffusion coefficient of hydrogen is comparable to diffusion coefficient of methane. So generally speaking, if a reservoir is gas tight for methane, it will be gas tight for hydrogen too. Finally, regarding materials, as Schlumberger but other companies said before, materials that are suitable for hydrogen exist, and we must divide into two cases. If a new underground storage completely dedicated to hydrogen will develop, the company have to choose what kind of material suitable for hydrogen and for the completion of the well, steel, elastomer, cements is suitable for the plant, the specific plant. Another case is when an underground gas storage, methane storage, is converted into hydrogen storage because material must be tested at reservoir condition, pressure, high temperature, presence of water, and presence of hydrogen, of course. So finally, we think as a group that with the right site selection, risk management assessment, the underground storage in our reservoir is technically viable.
Thank you, Donatella, so clear. Lisa, as I advance the most transversal of the group, perhaps the umbrella that covers the whole of our activities, and just in this moment we are advancing in the permitting, the final design, the permitting, the risk analysis, so determinants. So what are the main achievements of the group?
So safety is always an interesting one because we've obviously heard a lot this morning about the blockers and the challenges in the implementation of hydrogen, but safety hasn't really been mentioned because it almost comes as an assumption, because if it wasn't safe, we wouldn't do it. And that's very much the view of the general public as well. You know, certainly in the UK, the majority of the general public don't really care as long as it's not going to cost them anything more and it's not going to hurt them. And that's a really sort of key point when it comes to safety, because actually safety does cost money, and everything that the other working groups have been focusing on all has to encompass the safety part of it. And so one of the main achievements of the working group is actually the collaboration and assisting with the other working groups and supporting them through the safety side of things. As we know, hydrogen, as Gonzalo said, it's very volatile, it's very small, it behaves completely differently to natural gas, and we have a decade of research, a decade of experimental data on natural gas, and we just don't have that yet for hydrogen. So some of the challenges we've been facing is actually looking at the policies, the procedures, the way we're doing maintenance, the way we're doing emergency actions, the unexpected actions, and how we can actually manage those and what we even need to expect from them. And at the moment, there are many models out there. There's FAST, Order, Percy, Flax, so many models out there. But even at this point now, they are not giving consistent results to each other, let alone experimental data. I come from an experimental background. It's expensive. Again, it comes back to cost. But it's really the only reliable way to actually prove these computer models, especially as the models are getting smarter and smarter. And so one of the challenges we've really faced is actually looking at what this could be, what it needs to be, and especially when things like hazardous distances. We know that hydrogen's light, we know it's going to disperse, but we also know that if it ignites, and it's very likely to, the ignition energy is very low. It's possible that friction, or very possible that friction alone could ignite it. So not only are the dispersion distances larger, but the hazardous areas are, in terms of fire, explosion, potentially detonation, are all much larger. And it's all well and good saying, right, well, we'll just increase our hazardous areas, or we'll go as the models are, nice and conservative. But when it actually becomes a reality of looking at our compressor stations, our above ground installations that have already been sited for 30, 40 more years, where they have housing estates nearby, there's offices, there's parks, we can't just say, right, actually we need a bigger footprint that's twice as big, 4 times as big, 10 times as big. So one of the challenges we've really been working through there is actually how reliable are the models, how conservative are they too conservative, and how do they actually fit with the experimental data. And that's something that we've been working going forwards, and again feeding in with the other groups as to how we can help with the safety side of those, and it's definitely something we're going to be pushing through further, and supporting in any way we can to make sure that safety is not, it can't be an afterthought, because everybody is assuming that we've done it, and we need to make sure that we do.
Thank you, Lisa. All of you have shown us the way the TSOs and progressive TNOs have creating a maturity knowledge around our infrastructure. Obviously, you have managed, according with your specific knowledge, the advances in technical regulation, technologies, or specific procedure or practical guides, like is the case of PPI metering. But now we are far on 2020, where we were dealing with so theoretical aspects, and the project were 10 years for project. Now we are to be more practical. What are the specific challenges in this scenario that any of your working group are dealing in order to review our specific roadmap? Ivan.
Well, as we are moving from technical assessment to an implementation of the real projects, what we are focusing for the next year in working group 1 is the risking of the investment and enabling banking of the projects. As mentioned before, it's very important to transmit clearly that all the new infrastructures are safe, will be safe, not for the new build ones, but also for the repurposed ones. In this aspect, it's very important to align with the European standards, align all our internal protocols, design criteria, integrity assessment protocols, and all of this, for sure, will help us in reducing the permitting processes and reducing the cost impact in the projects. These are more or less the main ideas that will be followed in this group for the roadmap for the next years.
Thank you. Francis?
Yes, so in the group at the beginning, for many reasons, the choice for the driver was an electrical motor drive. So it's the advantage. One of the advantage is that it reduces also the risk. With the shutdown, the recent shutdown in Spain, turbines are coming back. So we have to reduce the risk. So an easy way, and in the case for most of us, and for my case, for Natron company, when I will have to propose some technology, an easy way, it's not a joke, it's easy way, it's not to be the first. But in the group, one of us will be the first to decide, and we can expect that in some project we are together and decide together. But for turbines and also for new technology, for centrifugal, it's a real challenge to decide. So the idea is to continue to exchange with manufacturer, that to persuade, to us that we can have confidence in these technologies when we have to order one of them. And also there's a technological aspect, because we are engineers and we like to have confidence in the technology, but also with contract. So we have to create and to continue, because we are already working like that, with long-term agreement with manufacturers to help us to decide.
Thank you, Francis. Marco?
I don't know if it is possible to project again what we have in the monitor, but I can explain without it. It's not a problem. Under an hydrogen-centric point of view, we have to move the separation system closer to the storages. Because if we need to use the storages, the cushion gas is natural gas. If you have the hydrogen grid, when you put the hydrogen in the depleted field, after the first time, the second time, the third time, you have, let me say in the brackets, dirty hydrogen. So you have to verify it. And what is the challenge? Is, again, with the supplier, a case study that say, what is your suggestion about the needs that if I'm using a depleted field, I have to purify hydrogen. So the next goal is to use the same method, but with a different perspective. We need to have a pure hydrogen. It doesn't matter 98, 99.5, we don't know. And then the case study could be more complex. What will be the scenario of the end users? Under the point of view of the methanocentric use of the membranes, we have only to take into account of the sensitive end users. But in the hydrogen-centric point of view, we have to need some information. In the population, who needs really the pure hydrogen? And where I have to put my separation system? Close to the storage, or I have to have two stages, close to the storage during the withdrawn phase. I have, let me say, a medium purity hydrogen to transport, and then I have a second plant that is only close to the end user that needs only pure hydrogen. We have a lot of job to do.
Thank you, Marco. Pepe, in your initial introduction, you have put on the table a lot of additional challenges, but more additional challenges, do you?
Well, at this moment, I think that we have a couple of challenges. First is the need of a clear regulation. As I mentioned, we are trying to replicate the natural gas market for hydrogen. Natural gas market has clear regulation for fiscal metering and protection of all the stakeholders in the value chains. We need to do the same for hydrogen. With the release of the gas and hydrogen package last year, we have some guidelines there, but we have to go to the details that are still not needed. I'm optimistic that I know that possibly in the next year we will have ready the rules for all the actors in this case in the metering chains. And the second challenge at this moment is the availability of 35 equipment. If we are going to a regulated market, we need, for fiscal metering, we need that the equipment are certified and are fulfilling the standard, the uncertainty requirement, the quality requirement. For this, we need laboratories. And unfortunately, looking to flow metering, there are not still laboratories in operation in Europe. I know that many stakeholders are working on that, and possibly in a couple of years we will have laboratories, like is the case of the one to be built by Enagás. But at this moment, the only certified technology for flow metering is Coriolis. Coriolis is a very nice technology for his field of application. But if we want to replicate what we have in the natural gas system for metering hundreds of thousands of cubic meters per hour, we will need to put in parallel many lines of Coriolis lines. While at this moment, with the technology for natural gas, with 1, 2, 3 meters is enough. So we need new certified equipment for the new technologies, because the technology is ready. What is not is the paper saying that it's ready.
Really, thank you, Pepe. Donatella, your point of view.
Given that hydrogen underground storage is technically viable, I think that one of the most important issue we have to face in the near future, as Marco said before, is the question of purity. We know two things. Storage plays a key role currently in natural gas value chain, but especially in hydrogen gas value chain, and especially for balancing demand and supply that is not constant. So, and we know that Europe is moving toward defining common specification for hydrogen purity, whether 98% to 99.5% of hydrogen in the flow. And implication for storages might be significant because, as I said before, because of the microbiological activity that consume the injected hydrogen and can lead to production of byproducts, impurities, and because of the cushion gas in depleted field, but not only, also in all the storages that have been used for years for methane storage. There is a residual gas, natural gas, that mixes with hydrogen. So if we inject 100% of hydrogen, we cannot withdraw 100% of hydrogen, at least at first storage cycle. So it means that the treatment facility at withdrawal point must reach what are the expectations of the end users. And it entails additional cost for storage operators. They must have also a gas quality management system, of course. So a possible solution could be align what are the needs and expectations of all the gas value chain from upstream to downstream with storage operators, TSOs, and end users. It will help to avoid uncertainty, avoid costly retrofits, and help the readiness of underground storage.
Thank you, Donatella. And new relations between groups are appearing, so I write them down for next steps. Lisa, safety. Safety is a subject that never has to understand that have enough. So what are the challenges, the specific challenges you have on the table?
I mean, I should probably start by saying that challenges in safety are good because it means that we're constantly developing and constantly learning and therefore constantly getting safer. But that doesn't mean it's easy. So some of the key challenges are the gap analysis. As I said before, we know so much about natural gas. So it's actually identifying what the continued unknowns are, filling those gaps, and actually sort of developing, I guess what you could say, the end product. We've already made great headway with the ATEX directive across Europe, but we've got a long way to go in actually getting consistent, reliable policies and procedures that actually can filter across the whole of Europe, so that we're all actually following the same hymn sheet. On top of that, I guess the other challenge is actually gathering that data, in that there's a lot of people, there's a lot of companies out there, there's a lot of test houses out there that are continuously testing and producing data, producing information. So actually gathering that round and being able to put that into implementation is key, firstly for getting that into the documents, but then also once we've got those policies, the actual implementation of procedures, the maintenance and so on, and how are we actually going to do that? What does that look like? And again, how much is it going to cost? And I guess the reality, and as it was said right at the very start today, that public perception on safety has got to be no question. There can't be a question on safety. So that's probably one of the biggest challenges, is making it not seem like a challenge.
Thank you, Lisa. And thank you, everybody, because when we were preparing the roundtable, we were a kind of multitude. We have 8 fantastic 5 minutes to summarize. I think you have put on the table the reality of the project. I think the challenge in 2020 was clear. Now we have additional challenges. 2030 is there in the short term, but it's clear that only from the collaboration we have simplified the problems and get clear solutions. I think the project is an example of this collaboration because it is not a question of TSOs and ATNOs. This is, I think, the great advance of the project was to involve the OEMs, the different associations, sectoral associations, that EPRG, for example, that is working from 30 years in pipeline and materials characterization. So now we are an environmental knowledge, and we are comfortable because we are creating, developing, and reinforcing the maturity. So I think in this way, the background of the TSOs after 50 years with clear KPIs of safety, integrity, cost effectiveness, and sustainability are going to be a reality in the early 2030s. So thank you so much to any of the teams, not only to you, because you represent great teams of collaboration with 16 members. It's not easy to balance all this group. So thank you very much for your participation. Thank you for sharing your knowledge, and thank you because I am writing down a lot of new tasks. So next week we begin to work again. Thank you so much, and thank you for your attention.
Can you hear me? Yes? Okay. So. No. Now, yes. Okay. So, what an interesting roundtables. We are enjoying a lot all the technical advancements that are happening around the hydrogen value chain. Now, I change my hat from being a host to being a speaker only for 10 minutes. Then I will rechange again my hat. So let me highlight during 10 minutes the key advancements that have taken place during the first year of this hydrogen observatory. But first of all, why a hydrogen technology observatory? As our CEO Arturo has already mentioned at the beginning, the technology is crucial to make the green hydrogen competitive. As was highlighted in the latest World Hydrogen Summit 2025, the success of green hydrogen as a central pillar for the sustainable energy future is driven by technological advancements. We are witnessing, as we have listened today, we are witnessing remarkable developments during the whole roundtables, and these remarkable developments is already positioning the green hydrogen as a central pillar in the energy landscape. That's why 1 year ago, at this same event, but in another place, we launched the Hydrogen Technology Observatory as a catalyst for the exchange of technical knowledge and technological developments along the hydrogen value chain. The main functions of this observatory is to share the state of the art of the technology, identify technological trends, and anticipate technological advancement, as well as share best practices in the field of technology and innovation. But apart from that, although launched and promoted by Enagás, this Hydrogen Technology Observatory is a collaboration between all its partners. Okay. till now, close to 60, but not yet. Maybe next week. We are 59 members, and thank you to all of them that are with us here today or following us on streaming, have joined the observatory. We have promoters, we have technology centers, universities, as well as both producers and consumers. The number of members, leaders in their sector, the respective sector, clearly reflects the maturity of this industry. This year, on February 2025, we launched the Technology Intelligence Working Group, presenting a proposal for the key lines of interest for technological development. After receiving feedback from our partners, we updated these key lines of interest, including a new one related to the importance of digitalization, as you have realized today. Is the key line of interest number 11. We have key lines of interest along the whole hydrogen value chain, starting from production, moving to transmission and storage, continuing with end uses, including mobility, obviously, land transport, aviation, maritime, power generation, and heavy industry. Apart from that, we have cross-cutting activities, like already mentioned, measurement, importance of talent, digitalization, the importance of safety, and social acceptance. We have been tackling these key lines of interest around the first 3 roundtables, and we will continue in the last one, that in 3-4 minutes we will start. But I would like I am pleased to announce the first collaborative report that will be soon publicly available about League 5 in relation to maritime decarbonization, thanks to the green hydrogen and other green molecules, thanks to the partners that are working on this report with us publicly, and soon it will be publicly available. As a follow-up, I have been informed that Fundación Hidrógeno Aragón will be the leader for the next report on League 1, that is really important, the hydrogen production. Thanks all the partners that are working with us, the ones that are working and the ones that will be working with us. Okay, it's important. This observatory is a collaborative activity. I think I am on time, but it's not working very well, the clock, so tell me if I am not right. Okay, since the last technical day, we have organized a lot of workshops and events. As a summary, we organized a workshop on the first one on hydrogen storage with our partner H2Site as well as Storengy. After that, we made an event in the French embassy about technological challenges in the deployment of green hydrogen infrastructure. This last December, we organized another workshop on land mobility, I would say a very interesting one, all of them, where our partner Gasnam, Natural Transport, collaborate with us, as well as Westport and Volvo Truck Spain. I think it was the last month, or 2 months ago, we organized another interesting workshop related to electrolysis system, where our partner Repsol and Fundación Hidrógeno Aragón took part of it, as well as we had the privilege to have with us 2 companies, Accelera by Cummins and Nordes Electrolyzer, informing us about the latest developments in their PEM and alkaline technology. And here we are today, sharing with you what we have achieved, what we are going to achieve in the short term. I'm happy to announce that we are preparing with some of our partners a very interesting workshop that will happen the 16th of July in relation to decarbonization in the maritime sector. A very interesting one, and happy to have you there. So if you want to be informed about our workshops and events, we have a newsletter where you can subscribe to it. Apart from, we have a LinkedIn profile where we, for this observatory, where we share the latest reports, advancement on the deliverables that we are developing. And please join us in this LinkedIn profile. So that's all. So now I change my hat from being a speaker to being a host again, no? And okay, I put here. Thank you. Now I will introduce the last but not least roundtable. I think it's a very important one. As our CEO has mentioned, the R&D is really relevant to the deployment of the green hydrogen infrastructure. In order to achieve a strategic and technological autonomy, the investment in R&D is essential. Developing homegrown capabilities in critical areas, as well as promoting collaboration between partner countries. That's why now I present our next moderator, Susana de Pablo, the Engineering, Technology and Digitalisation General Manager, that will be the one moderating this very interesting roundtable. So please, Susana, come to the stage, and the rest of the panelists. Thank you very much.
Good morning, everyone, again. Good morning, everyone, again. This is the last roundtable, and we hope that we are going to. I'm not going to say the best, but almost. Okay. If we analyze R&D projects related to hydrogen across key European funding programs over the past 5 years, focused strictly in research and development, there are more than 700 projects. Wow. Yeah. 700 projects. The current Horizon Europe program stands out, accounting for more than 500 projects, while its predecessor, Horizon 2020, supported almost 160 projects. We have gone from 160 projects to 200 projects. Together, these initiatives represent a total budget of over 3.338 billion euros, as Arturo told us in the first part of this event. Much money. These R&D projects typically benefit from grant funding covering between 50% and 100% of the total cost, demonstrating the strong public commitment to advancing hydrogen technologies. Looking at the top 10 participating countries, Germany leads the ranking, followed by France, Italy, and Spain. These figures underscore the strategic importance that Europe is placing on R&D as a driver for implementing the EU green hydrogen strategy. At Enagás, we are currently involved in 70 R&D projects, 90% of which are focused on hydrogen technologies. Of these, 14 are collaborative projects that bring together over 60 partners from both European and national institutions, with a combined economic value of more than 60 million euros. All these projects are supported by public innovation funds. Now, I would like to introduce the members of this roundtable, starting with Javier Navarro. Javier, welcome. Javier Navarro Espada is a member of the Hydrogen Europe Board of Directors. He is an industrial engineer and career civil servant. He represents the Aragon region in the regional pillar of Hydrogen Europe. He was General Director of Industry of the Government of Aragon for 22 years. Since August 2023, he has been technical and political advisor of the Department of Presidency, Economic and Justice of the Government of Aragon. He is deputy to the president of the Aragon Hydrogen Foundation. He has also held the vice presidencies of HERAMP, a HIER, the European Associations of Regions, or electromobility, hydrogen and fuel cells. Secondly, Dr. Robert Judd. Welcome. He is Technical Director at DNV, representing the European Gas Research Group, where he has been Secretary General for nearly 13 years. Robert is a chartered process engineer and has a PhD in physical chemistry from the University of London. He spent 4 years as a research fellow in the University of Cambridge Chemical Laboratory. He worked for over 20 years in the technology arm of the UK gas industry, with projects around the world, including Asia. Leading the European Gas Research Group since 2012, he has managed an association of 30 major European companies. He has also led or contributed to the production of research roadmaps for Hydrogen Europe and CEN. Robert is a member of Singapore's International Advisory Panel on Energy and has chaired the Gas Market Advisory Panel for Singapore's energy regulator. And thirdly, here is Marina Holgado. Welcome, Marina.
Thank you, Susana.
She is a chemical engineer and energy engineer with a master's in renewable energies, hydrogen, and fuel cells. She began working in the hydrogen sector in 2018 at AIREMA Energía y Medio Ambiente, and from 2020 to 2023, she coordinated a hydrogen technology collaboration program of the International Energy Agency. She is currently the technical director of the Spanish Hydrogen Association and technical secretariat for the Spanish Hydrogen Technology Platform. Is it correct?
Yes, thanks.
Okay, my first question is for Javier. Javier, what is your vision for the role of R&D projects as a catalyst for the development of the green hydrogen economy across its entire value chain, including production, transport, distribution, and end use at international and European levels?
Thank you. First of all, thanks to Enagás for organizing this interesting event and for inviting me and the European regions to this event too. The regions, we are bugs in Hydrogen Europe, because Hydrogen Europe is the hydrogen-related industry, and that was during more than 20 years. But now, precisely because Hydrogen Europe has like a primary goal to promote hydrogen like a key enabler of zero emissions society, is because they accepted to have us, the regions and the national associations on their structure. Hydrogen Europe has one agreement with the Commission, and they together they conform the Clean Hydrogen Partnership. And if you analyze the budget, the funding about European projects, you can see for each euro that the Commission put, Hydrogen Europe put another euro. And that's important. I belong to the Aragon government. I am assisted permanently by the Aragon Hydrogen Foundation. The Enagás is one of our trustees, and they collaborate very much with us. What about the research and development in green hydrogen? But I think that you said this very a lot of times. We has to enhance the competitiveness, and the R&D has to enable a feasible energy transition. That means that before anything, we have to reduce costs in all links of value chain. We have to improve efficiency, and we have to enhance durability. Everybody can say that, but it's very important. But we only can do that in a systemic improvement. We have to watch all the elements of the change together. And this hydrogen value chain is not only a list of physical elements, is not only a list of computer and telematics application, and it's not only a list of new materials and hydrogen carrier. There are another kind of important things. For example, the demonstration projects. We have to demonstrate the world that this economy, hydrogen economy, is feasible. And we have to study very much how to integrate green hydrogen into key industrial sectors. And even we have to know what are that sectors, because some of them are very evident and others they are not. And we have to develop hydrogen valleys. Hydrogen valleys is one concept, it's like one ecosystem of all the hydrogen value chain, and it's a little experiment, but that little experiment is growing and growing and joining with another hydrogen valleys, trying like in one crystal. We have nodules, and we can go joining all them. And it's very necessary to generate precise and accurate data, such as safety and quality standards, materials, the footprint of the different elements, the incidence on socioeconomic factors, that's research too, the market mechanisms, the new business models, and even we should research about history, about similar situation in the world where we have one crisis and we have to solve and to find new solutions, and we could speak about smart legal frames, because we are improving very much our normative, but we can think more about that. I repeat, research and development is critical in order to generate reliable data that will provide the essential basis for solid policy and political decisions, solid and clear investment decisions, industrial strategies, and important social acceptance.
Okay, thank you very much. Now I would like to move to the same question, but in Spain. Marina, what is your vision for the role of R&D projects in catalyzing the development of the green hydrogen economy across its entire value chain at the Spanish level?
Well, definitely, as Javier was saying, and you were saying before, R&D is still very important. We all know that hydrogen technology is commercial, is out there, but R&D is still very relevant for cost effectiveness, for more efficiency of the technology, and we still do that. And as Emilio was saying before, the Spanish Hydrogen Association Census of Projects tracks 80 R&D projects in Spain and over 100 demonstrator projects, so we have the projects there. We also have a very strong network of researchers, Spanish researchers, that we gather in the Spanish Hydrogen Technology Platform that I'm representing today. This is an initiative by the Spanish Hydrogen Association, funded in 2005, and it is funded by the Ministry of Science, Innovation and Universities every 2 years. So we, by the mandate of the ministry, we need to gather all of those that are researching hydrogen technologies in Spain and put them together to work. to see, okay, where are we? What are the main barriers? What are the priorities? And how do we need to start moving? So we organize in 5 working groups to cover the whole hydrogen value chain. And each of these working groups is currently analyzing what are the barriers that they are experiencing in the technology and what are the priorities that we need to move forward, right? So first working group is hydrogen production, of course, and they are seeing, for example, the reliance still on critical materials, for example, for PEM electrolysis. So we are talking platinum, titanium, and reducing this reliance and these components will not only go to cost efficiency, but also geopolitical strategy independence. So this is very important. But in hydrogen production, we not only focus on electrolysis, we have also researchers working in catalysts for biogas, bioethanol reforming for hydrogen production. Second working group, we have distribution, transport, and storage of hydrogen, very important here. Yeah. And we are working on material compatibility. We are also working on cryogenic storage, underground hydrogen storage. So all of these very important, and we have Spanish researchers working on that. And then we have 3 working groups focusing on applications. So for example, hydrogen mobility uses, and they are working on more efficient and lighter onboard hydrogen storage systems. And a more, we also, Pepe mentioned before, the metering systems. This is also very important in the hydrogen refueling stations. We need to be very precise on how much hydrogen we are fueling to the cars for pricing the consumption. And we still need to be a little more precise on this system, so we are working on that in R&D. We have a working group on hydrogen uses in industry, and they are working on how the hydrogen combustion affects the environment and how this should not affect the final characteristic of the products, say glass, cement, etc. So what are the materials that we need to have in our oven so hydrogen combustion does not affect, and the temperature that we reach does not affect final properties of the materials. And also in the industry working group, they work on security and safety that we were saying before is a very cross-cutting issue, and they are working on more sensitive sensors for hydrogen leakage, for example. And we have another hydrogen uses working group, last one, that is kind of all the rest, because hydrogen, as you know, is very transversal and has many, many uses, and this is called uses in electricity grids, buildings, auxiliary systems, and power backup. So, as I mentioned, lots of things that we need to cover in research, but we have researchers in all of these points, and they are working in hydrogen turbines, of course, and also they work specifically in fuel cells. So are working also in PEM fuel cells, enlarging the life cycle of them, and also recycling. It's very important. We were mentioning these critical materials. Once we have them there, let's not get them to waste and recover it. So this is all very important. We have Spanish researchers working on all of this, but it's also very important to develop manufacturing, Spanish manufacturing, and we are saying this European Net Zero Industry Act coming forth, that we will have some resilience criteria limiting extra European origin of components for electrolyzers, fuel cells, hydrogen storage. So we need to ensure that we not only have researching, but also manufacturing these very key components. So I encourage you to visit the Spanish Hydrogen Technology Platform website and also our catalog of technological capabilities, where you will be able to see what our researchers are doing, what their projects are, the main lanes of research. Thank you.
So the challenges are clear, and the collaboration is crucial in this point, as we could see. Dr. Jad, looking at your GIS background and experience, how do you think the focus on R&D among its members companies is changing in relation to new gases involved in the energy transition, particularly hydrogen? Is this a new trend, or does it already have a long history?
Thank you, Susana. I say thank you to Enagás for inviting me to come along today. I think the change in focus is clear from this room and the number of people in this room. I think if we'd done this 10 years ago, I think we would have seen a very different audience. It's great to be here to be able to talk about the R&D perspective. I was listening to the last panel and they talk about asset readiness, we talk about R&D, and really they're just two sides of the same coin. There is assets are ready, but there's a lot that can be done to make them more ready and to bring down, of course, the cost of this transition to hydrogen and to new gases. And I think R&D will always play a role, and it's great to see the resurgence in R&D. I mean, just from a history perspective, you say, is this a long sort of trend? Does it have a long history? I mean, GERG has been around. I don't know if everyone in the room knows who GERG are, the European Gas Research Group, or the European Research Gazière, if you want to go for the French acronym. But we've been around. We are the first. We are the oldest gas association, actually, in Europe, in Brussels. And we formed along with what was then a vertically integrated gas industry, only 5 members at the time, when R&D was critical, collaborative R&D was critical for getting the industry through a major transition. And that transition was the transition away from town gas to natural gas. So we were trying to take all the hydrogen away and replace it with methane and natural gas. And it's interesting that I heard Jose say this morning that we've been dealing with hydrogen for over 100 years. Actually, it's, I think, 213 years in the UK. The Gaslight and Coke company was producing town gas, and hydrogen, of course, a critical part of that. And I do some work in Singapore, and Singapore's now looking at their town gas industry, which still exists, and instead of getting rid of that, they're saying, can we add green hydrogen? So, you know, there are significant structural changes occurring in the industry, and I think GERG has been at the heart of many of these, and the transition is, this is probably the biggest transition we've ever faced as an industry. And, you know, when I joined the British gas industry, which is too many years ago to mention, there was a feeling that it was a very mature industry, a feeling that most things had already been done. There was clearly new privatization. There was a focus on safety, of course, always a focus on safety, but also a focus on efficiency and shareholder value. And these things were very much driving research from an industry point of view in one direction, which was usually downwards in terms of money available. And the European Commission had no interest really in supporting an industry which was seen to be on the way out at that point, I think it's fair to say. And the message when I joined GERG, or before I joined GERG, which was 13 years ago, from policymakers was we have to electrify everything. And of course that didn't bode well for our R&D budgets. But I think over the last decade, and I think particularly over the last 5 years, this new transformation and this new transition has given a new lease of life to the industry and to R&D. I remember the days of British Gas Research when 15 years ago, I believe, we were part of National Grid at the time. We'd been moved from the various parts of British Gas as it broke up and the deregulation occurred. We were then part of National Grid, who then sold British Gas R&D, or Advantica as it was called then, to Germanische Lloyd, and then they sold it to DNV. And the same thing happened in the Netherlands with Gas Unie. They sold their R&D business, and it wasn't seen to be core. What we see now, of course, is the reverse is happening, and National Gas in the room have got a big innovation team. Gas Unie have got an innovation team. Well, clearly they're still working with the likes of DNV, but they are very much focused on delivering this transition. And R&D has really evolved, and not evolved, but I think there's been a very rapid transformation to deliver and implement the results of the R&D that we've been working on for many years. I mean, GERG was working on or actually pulled together the Naturally project about 2 decades ago, almost 2 decades ago now. And that was really the first look at how you would introduce hydrogen into gas networks. And since then, I think it's fair to say that the results, the number of projects that have developed, at that time I could count the number of projects on the fingers of one hand. We heard today that Spain has 360. It's incredible. I can't keep track. Every day there are new projects. The results of that R&D are now being implemented. And I think all our member companies, and Enagás is one of our most prized. They're all prized, of course. We have gas companies, we have universities, we have research associations. We have other associations such as Hydrogen Europe Research, European Biogas Association, metrology institutes, all working with us to collaborate to ensure that the results, the research is being done to bring through this transition, which is being implemented so rapidly. We're inventing a whole new industry here. You know, the gas industry has transformed into a very different industry over the last decade, and that really is the message that the 2030 is just around the corner. we do need to make this happen. People are implementing hydrogen in a way that works. As you said, Marina, the technology is there, but there are a lot of improvements that need to be made to bring costs down to ensure infrastructure is ready. And the R&D that's being done, and Gerge is doing and collaborating with, and our members are doing in-house, and often sharing results. And I think particularly when it comes to safety, it's great to see that there is a lot more sharing, and Gerge is really at the heart of that sharing process. So yeah, it's been a long process, but the last 5 years have really been incredible in terms of the rate of transformation of the approach that the industry's taken to R&D. That's how I see it from where I sit.
Yes. Yes, the speed is incredible. Okay, returning to Javier, given your global perspective on hydrogen R&D over the years, are there still gaps in the hydrogen technology value chain that need to be addressed? Where should our efforts be focused in the coming years to achieve a significant leap in technology and reduce the price LCOH in line with market demands?
First, let me change the order of the answers.
Okay.
You will understand why. I am an engineer. Normally I speak on the focus of the engineering aspects. And then in my opinion, we can do one list of priority areas to reduce the levelized cost of hydrogen. I think that all you were talking about it during this morning. Electrolyzers efficiency, lower capex, operational flexibility, scalability for large-scale hydrogen production, energy storage, mainly to manage renewable energy variability, hydrogen hubs. One of the important tools for it are the primary hydrogen ecosystems, the hydrogen valleys, where the regions are very involved, to promote later of that first hydrogen valleys, large-scale production hubs to benefit, like I said before, from economies of scale and industrial applications, finding tailored solutions to key sectors like fertilizers, steel, refining, mobility, and many things that we can find to stimulate demand. If we have no demand, it's difficult to get a good production. But now I am going to consider another not so technical aspects that are very important for the Hydrogen Europe board. We might find best formulas for incentives for public funds and solutions and appropriate regulations. Like I said before, we have to improve working of different forms of research and development, focusing in the technology, but in other hand, focusing on social and legal aspects. And there are important research projects, for example, about the ecological transition, taxes, or different ways to not only giving money, could be saving money. It's very easy to understand that. And now I am going to talk about the gaps. Yes, there are still critical gaps that limit very much the adoption of hydrogen. The technology is in a very good position, is growing very fast, but I want to give you like a decalogue summarizing the main challenge. First of all, high cost against fossil fuels, insufficient infrastructure. Thank you, because you are working very much on it. You have a very, very big compromise. Safety, we need a conform the hydrogen safety. We cannot allow any accident in the same that in another technologies, the connected cars, the genetic areas. We cannot allow accidents on hydrogen. Safety drives us to regulation and standards to support technological development, secure investment decisions, and social acceptance is important, I say you. Energy system and grids integration, mainly with renewable energy sources. Stable and bigger demand is necessary to consolidate the hydrogen economy. Circular economy, we were talking about very few minutes ago. Social acceptance, international cooperation that imply economics and social research. We have to choose very carefully profitable alliances with loyal partners. The world is very big. It's very large, and not all the partners are so loyal. And last but not least, and that's the reason because I wanted to finish in this order, for me, completely related with research and development, we have one gap of time. We have a risk of not acting in time. And some European Union business and political sectors are not fully aware of the economic and social consequences of losing global leadership, and with it, to lose technological and energy autonomy. This is the game, and this is the bet. It's crucial to research about the way to transmit precise data supports and benefits demonstration, like I said before. And this is my opinion, and I am sure that it's the same opinion that the Hydrogen Europe Board.
Thank you very much for saying your opinion with us. Robert, how has GRD evolved, and what is his main role in the projects it's involved in?
Yeah, very good question. I think it's transformed rather than evolved. And I think the last 5 years have seen the biggest change. I remember when GRD was run by one person, which it was for many years. We now have an office of 7, soon to be 8, based in Brussels. We've restructured ourselves entirely on the basis of the transition. We have 4 working groups. Hydrogen biomethane introduction, CCS, methane emissions reduction, all around emissions reduction and that push to net zero. We have roadmaps that we're pulling together for the industry, which are very much aligned with the external roadmaps of the likes of Hydrogen Europe. We are working with Hydrogen Europe. We work with CEN on standards. We've done 2 flagship projects on biomethane and hydrogen, looking at technology gaps or barriers in introduction of hydrogen and biomethane. We currently have on the table, we're working on 17 European funded projects of total value of around 80 million euros, and many of those are Clean Hydrogen Partnership. We have European Metrology group projects, we have Horizon Europe projects. Our role really is to ensure impact, ensure the results are we work with a stakeholder group, we bring the advisory groups into the projects, and that usually consists of our members and external organisations in the heart of the kind of stakeholder community that we're part of. We ensure that the results are communicated. We provide a lot of expertise from our membership, from all the various members and their own research communities. Our working groups have, the hydrogen one's got well over 100 members, for example, from the industry and beyond. So that expertise is brought into those projects to ensure that what we're doing is fit for purpose, ultimately ensuring impact and ensuring the results of these projects are not left on the shelf, and that they are used, as I said earlier, in ensuring that this implementation happens, and that we can ensure that the understanding of, for example, infrastructure repurposing, ensure that standards are fit for purpose, so we can contribute to regulatory change. All of these things, I think our role is to glue everything together and ensure that that research is used, and that given the time limitations we have, that can be done in a very coherent way with the biggest group and most coherent group of stakeholders that we can pull together. So that's our role, and that is, I think, how we've transformed, because I wouldn't have been able to say any of that 5 years ago, but I'm pretty confident that that's what we're doing now. So yeah, that's pretty much where we are.
Thank you very much, and we have run out of time, but we have 5 minutes of the last roundtables. And Marina, briefly, please.
Yes.
Which data or conclusions would you highlight regarding the R&D projects carried out or currently underway in Spain with the Spanish public funding instruments such as CDTI and IDAE?
Yes, so CDTI, IDAE, together with the state research agency, they have been funneling funds from the Ministry of Science and Innovation and also the Ministry of Ecological Transition to hydrogen projects in the last few years, and they are all very happy with the results. It's complicated to synthesize the main lessons learned because hydrogen, as we have been seeing during all the workshop today, is very transversal. But we have seen that IDAE has channeled 222 million euros to 64 projects only in their line of funding, Cadena de Valor, hydrogen value chain, that is the more R&D focused. And also CDTI, across their different funding lines, has channeled 190 million euros in subsidies and 60 million euros in credit to 109 hydrogen projects out there. So many research projects has been funded by CDTI and IDAE, and both of them agree that they have seen over these past years how these research projects are becoming more robust. They have a very good consortia and very good strategies to development of these technologies way beyond the allocated time for this funding, so they are very happy with this. And this is why the Hydrogen Technology Observatory and the Hydrogen Technology Platform are very useful tools to bring together all the researchers and put to play the lessons learned on these R&D projects. So we learn from what has been done and we build from there.
Okay, thank you very much. Thank you very much to Marina, Dr. Jad, Javier, for your interesting insights. As conclusion, the research and development is crucial in this moment for the deployment of the green hydrogen. The green hydrogen is not a dream, it's a project. There's a big difference. And thank you very much to everybody.
Thank you.
Yep. Thank you very much to Susana de Pablo and the rest of the speakers. Very interesting roundtable, doubtless. Right now, we have the pleasure of having with us the Enagás General Transition General Manager, Natalia Latorre. Please come to the stage, and she has the difficult duty of making a nice summary of today's event. It's not an easy job. Thank you very much.
Ask for this table because I have many pages to summarize after this, I will say, amazing and enlightening session that we have this morning. So for me, it's a real privilege to be in front of you and try to summarize what has been said during this morning. On the morning, we have the opportunity to reflect about the state of the hydrogen technology and also to explore deeper the technical aspects of hydrogen through the challenges that we face as a sector. After the program, I must say that clearly we can confirm the progress that we truly made during this year that is remarkable. I would like to extend my gratitude to all the speakers and panelists for their contributions to these discussions. Your expertise, your passion, and your dedication made the session a success. Of course, thanks to the people that are here present, but also the people that are following this session via streaming. Let me share what are my takeaways. I don't know, it will be yours, but at least it's mine, so I have the opportunity to share. Arturo, Gonzalo, Enagás CEOs, at the opening session said something that for me is, I will say, my daily activity. There will not be European hydrogen market without infrastructure. I think this is a key message that we need to think about that. He reminds us that 60% of the awarded projects in the European Hydrogen Bank, the last one, requires pipelines to connect production and consumption, and with an average of 384 kilometers. So this is a long pipeline. Also, he announced that in Enagás we formalized the signature of the grant agreement with INEA for the Spanish hydrogen backbone. That, of course, this is a message from my Enagás people that we need to continue pushing for the delivery of the Spanish backbone. Our key speaker, Emilio Nieto, I think you set clearly the scheme for the rest of the morning. You shared the overview of the Spanish hydrogen projects, 9 in operations, 6 FIDs already taken, and expected more than 60 for this year. Let's see what happened. Also, he shared the technology that these projects are using or they will use, application split, and the barriers for the deployment of the hydrogen ecosystem. Barriers or challenges that it was, I will say, the matter in all the roundtables that we had. The first roundtable was focused on transformational role of digitalization. And we see that the main challenge identified by our panelists were achieve real efficiency, human factors, I like that, and transfer economy, building models, and play before things are happening. Roger took the sense or give us the sense that the scale and the urgency of the transformation ahead doesn't need trial and error. So we don't have time, and I will come back to the time that it was mentioned in the last panel because I like. But clearly, we cannot do that. We need to approach in a different way, and we need to build these digital twins that are essential for increasing predictability and accelerate the implementation. We need to develop computational models that incorporate the uncertainty. From Natalia, we learned that building information modeling is set to transform not only the design, the construction, and the operations of hydrogen infrastructure, but also the way that the work is performed, important as well. From Nina, it was stated that truly operational digital twin is the one that integrates operational technology, OT, and information technology, IT. It was also highlighted that the artificial intelligence will play a key role in taking these decisions to the next level. The second roundtable focused on the critical contribution from original equipment manufacturers towards a robust hydrogen network in Europe. Vauhini, Marco, Holger, Olga, and Federico, representatives from Bruncar, Baker Hughes, Mannesmann, Endres and Hauser, and SLB, outlined their developments and also the challenges in hydrogen compression, instrumentation, gas turbine, and valves technology. Congrats to all of you and your companies for the great progress that you have made. Clearly, we have challenges, and I will refer to the material science to ensure durability for high-pressure conditions. We know quite well that we are working in a high-pressure environment. Energy efficiency, regulatory, and safety standardization that I will come back later to safety. This energy transition is all about collaboration, and this is exactly what we address in the following session. For the one that refers to the challenge and opportunities for the integrated of hydrogen transmission system, we have brought important concept of collaboration across all the TSOs and other companies. We are talking about H2GAR and the 16 companies that are there. We review quickly. We review the work of 6 working groups. So my challenge is if I address in 1 minute each of them. From Iván Montero, Working Group 1, They are assessing the impact of pure and blended hydrogen on existing carbon steel pipelines, and now they are moving towards more an harmonization, design, qualification, and repurposing criteria. Congrats for the updates that you mentioned regarding the standards that now are less conservative. In Working Group 2, Francis Barnier focused in getting deep knowledge about H2 compressor technology, especially for high flow rates, so for H2 Med. Pedro, it will be good for us. Quite interesting to explore the opportunity to adopt hydrogen turbines instead of electric motors. And this is one of the learnings probably from the Spanish and Portuguese blackout. No? I like that they are positive with the progress that the technology is doing in compression and turbines. Hydrogen purity has been mentioned in many sessions. Is the Working Group 3, and Marcos Tarenzi explained how important is the separation and purification that are elements, key and essential elements in some locations, especially storage. From Pepe, we learn about the hydrogen metering that has been developed, although we are conscious that the lack of specific standards for hydrogen because there is no accredited hydrogen flow testing laboratories. So let's see if next year we can share good news on that. Working Group 6, Donatella explained the underground storage that is a key element in the operation and value of hydrogen and how this is bringing into the decarbonized energy system. Main aspects to consider: the microbiological risk due to these chemical reactions that can be created, but the good news is that with the proper selection material and doing a proper risk management, it's feasible to develop hydrogen storage. That is great. But of course, in the challenge, it was also mentioned the purity specifications. And then safety. Lisa, you mentioned safety is the core of the activities of any TSO and future HTNO, and it's critical to work towards practical implementation of safety measures, especially in the operations and maintenance. And this is what this working group is working on, also working in promoting a supportive safety culture. Igor, then you came and you explained all the progress that has been done in the Hydrogen Technology Observatory. It's amazing, to be honest. When we started a year ago, what has been able to develop, to have almost 60 leading companies part of it is a great achievement. This encourages, I'm pretty sure, all the people that are part of this project to continue working, and of course, welcome to this first collaborative paper about maritime decarbonization. So it will be great to read that. And of course, this is a formal invitation for others to join and be part of this Hydrogen Technology Observatory that is the place that we really think that we can exchange technical knowledge and create the ecosystem that will drive this technological advance that the hydrogen market requires. Then, in the last panel regarding R&D, we really see how they are a catalyst for green hydrogen across the value chain. We learn about these 7,000 projects with more than 3.3 billion euros of budget. I must say that I learned the Champions League in the ranking of who is having more projects in research and development: Germany, France, Italy, Spain. With Javier, Robert, and Marina, I think all get the sense that we need to demonstrate that hydrogen economy system works, that I like that the idea that with all these projects, we generate reliable data for taking political decisions, that I think is important. And then I need to confirm that I listened or I understood correctly, 250 years that we deal with hydrogen. So it's a lot of time, so it's not nothing new. So we need to build on that. Safety, cost, efficiency, value for shareholders is important, and it's important to understand how relevant is research and development for delivering this transition. And I will end this roundtable with one gap mentioned by Javier that probably was not before, the gap of time. We can lose time because we cannot lose leadership and technology. So important to consider. So this event wants to show you the immense potential of hydrogen as an energy system. We have challenge and will remain. We need to, that includes technical feasibility, cost efficiency, regulatory uncertainties. But all these discussions have shown innovative solutions and collaborative efforts are driving the hydrogen economy forward. Last year, I took from this session one word, that it was collaboration. This year, I want to add a new one, that is standardization. Has been in all the discussions, in all the panels, how it's important to have hydrogen in the level of standardization that, for example, natural gas has. For me, I'm going to ask you again that you commit, as we did last year, three things. The first one is we need to spread awareness and the knowledge that we have. We need to speak up and talk about the progress that we are doing in the hydrogen ecosystem. We need to continue in the collaboration mode. It's impossible to deliver what we need to deliver by alone. So this is an important. And we have to build the hydrogen value chains based on our legacy business. But clearly, we need to introduce the innovation and the new technologies in the way that we approach this new energy system. With all of this, my last comment is that thanks for your attention. Let's go and make a difference all together. Thank you very much.